The International Space Station, in this view from the external TV camera outboard on the S1 truss that was installed on the station last month, about 45 feet outboard from the modules of the station, showing the forward docking port, pressurized mating adapter number 2 at the end of the Destiny laboratory, to which Endeavour will link up to tomorrow afternoon, docking scheduled at 3:26 p.m. Central Time, as the two craft fly over the Kazakh-Uzbekistan border. Currently, Endeavour is approaching the south coast of South America, along with the International Space Station. Endeavour currently trailing the station by just over 2,000 statute miles. From the middeck of Endeavour, Mission Specialist John Harrington, and joined just out of the field of view by Mike Lopez Alegria, his spacewalking partner for this flight, as they are in the midst of their work to check out the extravehicular mobility units, the spacesuits that they will wear for their 3 spacewalks outside the Quest airlock of the International Space Station beginning on Tuesday afternoon. You heard a moment ago Commander Jim Weatherby report that he was prepared to move to the aft flight deck of Endeavour and begin the procedures to power up the shuttle's robotic arm, the 50-foot-long robotic arm that will be used to initially grapple the P-1 truss segment on Tuesday, lift it out of Endeavour's cargo bay and hand it off to the station's robotic arm under the control of ISS crew member Peggy Whitson. Now on the flight deck of Endeavour, where Commander Jim Weatherby on the right and ISS Expedition 6 Commander Ken Bowersox on the left, begin the procedures to power up the 50-foot-long robotic arm on board Endeavour. It will be uncradled, unfurled, and tested, along with a payload bay survey of the P-1 truss segment.
Just wanted to let you know we are on the flight deck with you. With a couple minutes of KU left, we thought we'd watch some RMS power-up activities.
We've got you loud and clear, Tracy. How about us from Endeavour?
Thank you, Commander. I can hear you just fine. For Commander Bowersox, I'm wondering how launch is different, knowing that you're going to be gone for 4 months instead of 10 days.
Well, I guess the best part about it is I know that this wonderful experience isn't going to end too quickly. I've been looking out the windows and have been amazed at just how much I've missed in the last 5.5 years since my last flight. And I'm looking forward to the next 4 months up here in orbit.
Do you feel like you're on a homecoming?
Yeah, the trip into space was like coming home. It was fantastic.
For Dr. Pettit, how are you feeling? Did you take any Theragun yet?
I took the standard DESA medication for motion sickness, not knowing what the effects would be when I got on orbit, since I hadn't ever been here before.
How do you feel now?
Well, my cheeks are nice and pink.
Do you have any stomach awareness, or are you feeling pretty much normal?
Right now, I'm feeling very normal.
How do you find zero-G? Are you feeling comfortable and at home yet?
Well, it's something that takes a little while to get adapted to. I have decided that if human beings had prehensile feet, it'd be a whole lot easier. And as long as you're wishing for things like that, you may as well have a prehensile tail too. And I think you'd find if you had all of that equipment, it would come in handy up here in zero-G.
Does that mean you have bumped into a few things?
Well, it just means that if your hands are busy with objects, you're floating around the room, so you got to try to grab your feet onto something. And it'd really help if you had hands on the bottoms of where your feet normally go.
For Mr. Budarin, how is it for you flying into space after so long a period of time? Are you happy to be back?
Рады ли вы быть обратно в космосе, вернуться в космос после стольких лет, когда вам пришлось ждать полета?
Да, конечно, рад. И невесомость встретила меня довольно мягко. Я чувствую себя очень прекрасно и очень доволен, что снова в космосе с нашим экипажем.
How did the delay affect you? Were you impatient at all or frustrated?
Как на вас повлияла задержка с запуском? Волновались ли вы, ждали ли вы его с нетерпением?
Конечно, первый раз было волнение, а второй и третий уже довольно спокойно. Волнение было только из-за того, что не стартовали вовремя.
You say you were worried that, when there was the first delay. Were you worried for your personal safety or just worried that there might be a long
Вы сказали,
delay?
что вы волновались, когда была первая задержка. Означает ли это, что вы испытывали чувство страха за собственную безопасность, или это было волнение, связанное именно с общим, так сказать, делом, с успехом общего полета?
Нет, вы, наверное, немножко не поняли. Волнение было из-за того, уже после задержки старта, то, что старт не состоялся, поэтому волновался.
Thank you. Back to Commander Bowersox. I'm wondering how the delay affected you. Did you say goodbye several times to your family, or did you just leave it at one?
No, in fact, it's really funny. With multiple launch delays, what you find is the first goodbye is very emotional, and the second one gets a little less emotional, and by the time you get to the third goodbye, people just want you to leave.
Are you finding that you pick up exactly where you left off the last time you returned from space? Are you comfortable in 0G?
Oh yeah, I think the adaptation goes more quickly every time, at least for me, that I get back up into space.
Do you feel perfectly natural and at ease already at this point in the flight, or are you still readjusting a little bit to your state of knowledge from the last time?
I feel about where I left off the last flight. I'm really anxious to see how I'm going to feel after 3 or 4 months, what type of changes can still take place. It's been amazing watching Nikolai work. He can position things so finely, and he's so good at organizing big messes. If you could see the other side of the flight deck, or the mid deck right now, you see that we've got gear strewn everywhere. And Nikolai loves to jump into those piles of gear and just start tying things down and untying and moving things. He's fantastic to watch, and it's because of his months of experience on orbit.
I'm sure it'll be like that soon. Do you have any special plans for the handover?
I want to give Peggy and Valeria and Sergey a big hug. Other than that, I think we're just going to be so busy working, doing our assembly tasks, that we're not going to have very much time at all for fun type events.
For Dr. Pettit, have you had a chance to look out the window yet?
I've had a few moments to take a peek out the window, and I'll tell you, if you're looking up towards the stars, it is jet black, and you see these little points. If you're looking down towards Earth, it really makes you appreciate the planet that we live on.
Dr. Pettit, many people who've flown in space say that seeing the Earth from orbit has changed how they think about Earth and human beings and our place in the world. As a scientist, you bring a different perspective to it, I would think. How are you feeling? Is it too soon to say?
It's probably too soon to say right now. However, it does make you appreciate what we have for a planet. I don't think it's made me completely rearrange my spiritual beliefs after seeing the planet from orbit.
When you say it made you appreciate the planet, can you elaborate a little?
It's sort of like you're living in the burbs and you go for a camping trip, and when you come back to your house, you really appreciate it a little bit more than you did before you left. And this sort of goes with how far away you travel from home. And I'm sure in the future, when people are coming back from Mars, they're going to insert themselves into low Earth orbit around Earth, and they're going to consider themselves home. And here we are in low Earth orbit, and that's the end point for this particular expedition.
For Commander Bowersox, do you think, are you being treated any differently by your shuttle crewmates, given any special privileges perhaps because you're going to be gone for so long?
Well, they're making us work a lot less than I'm used to on my previous flights. Normally you have a lot of tasks to do, and 7 people divide those tasks up equally. Because of the way we've been training for our long-duration flight, the other 4 members of our crew, Mike, John, Paul, and Jim, have had to work 50% harder to make up for our shortcoming. And we've been amazed watching how much and how hard that they've been able to work. So I'd say they have treated us a little bit differently, and that they're sheltering us and making sure that they carry most of the load.
Well, that's good of them. Well, thank you all very much for your help and your time, and I wish you the best of luck on your stay on this ISS.
Great. We'll be looking forward to talking to you again.
This is Marcia then talking to you from your launch site. Hello to you all. For Captain Bowersox, you're finally on your way after all those years of trainings and weeks of delays. And is it hard to believe that you're about to move into the space station and start your mission?
Hi, Marcia. Yeah, it is hard to believe. But I can't wait. I've seen 2 or 3 sunrises during the last couple days, and I can't believe how many more I've got ahead of me. But I think every day is going to be precious up here.
You said before the flight that you were more nervous going into this 4-month mission than any of your short shuttle flights. And I'm wondering, have the jitters gone away, or are you still a little bit worried about being away from Earth for so long?
Well, there's still a little bit more unknown for me, in that I just don't know how I'm going to handle it all. I anticipate that it's all going to be fine. But I'm wondering if after 3 or 4 months it stops being fun and starts being a lot more like work. We'll find out after 4 months, but right now it's just fantastic.
Another question for you. How stressful were the launch delays? And I'm wondering how you spent those 2 extra weeks on Earth. What kind of earthly activities did you cram in there?
Well, for me, I wouldn't describe it as stressful. In fact, it was pretty much the opposite. Because we were completely trained, after we started getting the delays, we caught up on sleep, rested. Our sleep shift was a big thing. We were waking up at 6 in the morning and going to bed in the afternoon. By the time we had moved 20 days, we were going to bed around midnight and waking up around 8 or 9 in the morning. It was much more comfortable, and we all, I think, were in excellent physical condition because of that. And we got to work out a lot. So I think physically the delays helped us. The only thing I'm worried about is that it might shorten our mission. The ULF-1 pickup flight is not really coupled to our launch for its launch date. So they may arrive at the same time as they would have if we had launched on time. So Don and I and Nikolai are a little worried that our mission may be shorter because of that. But that'll be okay. It's going to be a great flight, whether it's 1 month or 1 year.
Dr. Pettit, how did you spend those 2 extra weeks on Earth? What did you do to enjoy the extra time?
Well, I caught up on a lot of sleep, and it gave me an opportunity to try to put on a few pounds before flight. And so I did a lot of eating, and then I did a lot more sleep after that, and then, of course, we have to go to the gym.
Oh, that gym part sounds pretty awful, huh? What were you doing a lot of eating of? What were those foods and meals that you were taking advantage of?
When we're in quarantine, they only want us to eat the food that they serve us, so I wasn't able to have any good home-cooked meals, but the food they give us is pretty good stuff. They've got people making sure that we get all our vitamins and minerals and everything's well balanced. So just eat what's put in front of you and then go back to the gym.
I have another question for you, Dr. Pettit. During NASA's suit-up pictures Friday night, I saw you on television lying in the reclining chair, and it looked like you were taking a nap. And I'm wondering, were you really so relaxed before your first space flight?
Yeah, we stayed up late the night before watching a movie, and I was just catching a few Z's.
What movie was that? Do you care to say?
It was one of these old movies with a Marine fighter pilot shooting down airplanes and everything. I can't even remember the name of it.
I see. Well, if my count is right, you've got 7 sons among the 3 of you and no girls. And I guess for Captain Bowersox and Dr. Pettit, since your boys are still so young, I'm wondering, how did you say goodbye to them, and was it the toughest part of departing for your journey?
Well, my boys are going to turn 2 here in a few more days, and they're just now learning how to use a telephone, and they don't quite understand what the concept is. So it's going to be kind of hard staying in touch with them. I think for this particular mission, it's going to be sort of like I fell off the planet.
And Captain Bowersox, how was the goodbye for your 3 sons?
Well, my sons took it pretty well. I think it was hardest for me. I miss them already, but you know, you just can't do everything at once. Sometimes to do important things, you have to leave the people you love. We have folks in our armed services, in different industries that are important to our country that do it every day. And we have to be willing to do that in order to move forward. And so once I put that behind me, then I just move ahead, and I don't think about it that much. I don't let the emotions get in the way. But I don't shut it off completely. I mean, it's a nice feeling to know that you're loved and that you miss someone that you love.
For Cosmonaut Dadarin, this will be the first time you spend Christmas and New Year's in space. And I'm wondering how difficult that's going to be for you, the fact that you will not be home with your wife and sons.
Вопрос господину Бударину. Вам придется в первый раз встретить Новый год и провести Рождество в космосе. Будет ли вот тот факт, что вы эти праздники будете отмечать вдали от семьи, представлять для вас какие-то сложности?
Но я думаю, никаких сложностей у нас не будет, потому что у нас наш экипаж это тоже семья. И я думаю, что наша космическая семья, вот на данный момент Кен, Дон и я, мы будем отмечать эти праздники вместе с нашими семьями. У нас хорошо есть на станции телефон, мы можем связаться, поздравить своих близких, друзей, родственников. И я думаю, никаких трудностей у нас не будет.
For any of you, but I guess for you, Captain Bowersox, I guess the big question is, were you able to smuggle any turkey on board for this Thursday?
No smuggling was required. NASA took care of us. I was just looking in my food locker, and I know there's already a turkey breast in there for me. I haven't looked at anybody else's, but I imagine there's more on board.
Well, you know, your mission seems to have fallen smack in the middle of the holiday season, and is that an extra hardship on top of everything else that you're dealing with here, being away for Thanksgiving, Christmas, New Year's?
Well, I think what it may do is intensify some of the experience. I think in some ways it may make it more pleasant. I can't think of a whole lot better places to spend Christmas than up in Earth orbit looking down trying to find Santa Claus.
Well, I hope you find him up there. I know Dr. Pettit's answer to this, so I'll just ask you. I'm wondering if you got any Christmas shopping done, Captain Bowersox, and maybe Dr. Pettit, maybe you managed to squeeze some in there at the last minute.
Well, I did get some Christmas shopping done, but probably not enough. I've got some little things positioned around the house for my family, but I'm going to make up for it when I get back. And I'm still going to see what I can do to make Christmas presents for everyone while I'm on orbit, and they'll just have to get their Christmas in March or April.
I see. Did you manage to take up enough coffee with you, Dr. Pettit, for the duration, and maybe even a little extra in case your return gets delayed?
Well, I got 100 packets of coffee for a mission that's normally 120 days plus, so I think if I borrow a few coffees from the shuttle crew here before they undock, I'll be set just fine.
Great. And for any of you, I'm wondering if you were able to see Don Thomas or talk to him during the countdown, and I'm wondering if you wish you all good luck, and is it still hard for you thinking that he should be up there now too?
Well, just for an example, this emblem that's on our shirt was designed by Don Thomas. And so he's with us every minute in spirit, and we think about him a lot, and we can only wish him the best. And we know that this has been very, very hard for him, so that's been the toughest thing for us too. But he's a big part of this mission. Everywhere we go, we see reminders of him, and there's no way we could not think about him.
I'm wondering if you had a chance to chat with him, though, before you lifted off.
We did not get a chance to chat. It's still kind of painful and sore for Don. When he talks with us, it becomes even more painful. So we're going to try and connect with him when we get on orbit or when we get home after he's had a little bit of distance. But this is a very, very tough thing to be so close to accomplishing a dream. Going up for a long-duration flight was Don Thomas's dream, and when he wasn't able to do it, it hurt him pretty bad. As the distance and the time heals that wound, then I think it'll be a little bit easier for him to discuss how much fun we're having on orbit.
Well, good luck and have a safe journey. Happy Thanksgiving, and I guess I better say Merry Christmas too.
All right, the same to you.
Receiving downlink television now of the orbiter docking system, which has had its docking ring extended today as part of the preparations for tomorrow's rendezvous and docking with the International Space Station. On board Endeavour, Commander Jim Weatherby, pilot Paul Lockhart, and mission specialist Mike Lopez-Alegria and John Harrington, along with the Expedition 5's replacement crew, the Expedition 6 crew, Commander Ken Bowersox, and flight engineers Don Pettit and Nikolai Budarin. Are about 2 hours and 45 minutes away from beginning their sleep shift. The two vehicles now orbiting over the Pacific, heading for the coast of the Baja Peninsula of Mexico, and then swing to the northeast over the central portion of the United States.
And a heads up, we are 2 minutes from a 7-minute ZOE. We'll be back from that at 4:25, but it'll be followed by 16 minutes of off the tail, which will be complete and back to good comm at 4:41. That, of course, is after your scheduled sleep time, so of course we'll be available here if you need anything. Otherwise, we'll say good night to you now.
Well, we're doing pretty well tonight, and hopefully we'll be fast asleep by the next time you see us. Thanks for watching out for us, and we'll see you tomorrow. Thank you very much.
With that, Lisa Nowak here in Mission Control, bidding a good night to the crew on board Endeavour, with a final call up about resetting the error logs on the data processing system computers, those general purpose computers that operate the Space Shuttle.
All quiet here in the shuttle flight control room, now just 15 seconds away from the terminal initiation burn. Very visible evidence of the terminal initiation burn, the initiation of the firing of the left orbital maneuvering system engine in this view from a distance of almost 9 miles away. Once again, this view from the television camera at the end of the Starboard 1 truss segment, showing the Soyuz TMA-1 vehicle docked to the Pirs docking compartment, and rapidly approaching the shuttle Endeavour, now just 1 mile away from the International Space Station.
19 Bravo.
4,000 feet now separating Endeavour from the International Space Station as it closes at a rate of about 5.5 feet per second, on course and on time to reach a point about 600 feet directly below the station, coming up about 15 minutes from now. This view of the station again through the sequential still video system, the S-band communication system. It's a frame refreshing imagery system that updates itself about every 30 seconds on board the shuttle, showing the International Space Station through the centerline camera mounted in the orbiter docking system.
Alpha Endeavour, com check.
Endeavour Alpha, we have you loud and clear.
Peggy, how are you?
You guys look pretty good out there.
We're just saying the same about you.
Endeavour Houston, we see you coming up on the Torva, and you are go for docking.
Copy, go for docking.
Pilot Paul Lockhart acknowledging the go for docking from spacecraft communicator Pat Forrester, docking now just 45 minutes away. Both Endeavour and the International Space Station approaching the coast of Ecuador as they move from southwest to northeast across the southern Pacific Ocean. All of Endeavour systems in great shape, and again you're looking right down the barrel of the payload bay of Endeavour at the P1 truss segment. That truss segment will be grappled by the shuttle's robot arm and handed off to the station's Canadarm2 robotic arm tomorrow.
Report. And help.
Now downlink television from Endeavour showing the Soyuz TMA vehicle as Commander Jim Weatherby aligns Endeavour along the velocity vector or V-bar directly in front of the International Space Station.
Houston Alpha on 2 for PMA2 arrival.
Go ahead, Peggy, on 2.
Yeah, everything is complete in step 1 and looks nominal.
Great news. Thanks, Peggy.
With the two docking mechanisms properly aligned, no station keeping will be required at 30 feet. Commander Jim Weatherby given permission to press in, now 28 feet separating the two spacecraft as they fly over Australia, about to begin a swing across the South Pacific. Again, this view from the television camera at the end of the Starboard 1 truss segment on the International Space Station. The twin of that truss, housed in Endeavour's cargo bay, will be unberthed and attached on the opposite side of the S0 truss, which is mounted to the top side of the Destiny laboratory of the station that you see in the field of view in the lower right-hand portion of your screen.
Houston, we have a capture light and break. Alpha, we have capture confirmed.
Copy.
Endeavour Houston, station of free drift confirmed. Great job. We had a breathtaking and groundbreaking view of your approach up to station, and we want to welcome Expedition 6 to their new home.
Endeavour arriving.
Maintaining a tradition, Peggy Whitson ringing the ship's bell on the Unity module of the International Space Station to mark Endeavour's arrival. 3 new residents.
Personal note, it looks like you guys fly that like you stole it.
Houston, thanks for your help.
And now we're looking at a videotape replay of the final approach of Endeavour for docking. This occurred just a few minutes ago We were out of a KU band downlink capability from the International Space Station at the time of actual contact and capture. This is the videotape replay of what occurred about 10 minutes ago. Again, this is a videotape replay of the final few feet of Endeavour's approach for docking to the forward docking port on the Destiny Laboratory, that docking occurring about 11 minutes ago at 3:59 p.m. Central Time. This was the final few feet as the two docking mechanisms approached one another for contact and capture. Again, this videotape replay of the final few feet of contact and capture. And there it was, contact and capture between the two vehicles at 3:59 p.m. Central Time over the southern Pacific Ocean just southeast of Australia.
Very nice ducking, maneuver. Beautiful. Good to hear you. Come in. All right. Let's go in. Connect.
Hatches open between the shuttle and the station at 5:31 p.m. Central Time. Endeavour's crew now boarding the International Space Station. Commander Jim Weatherby first into the Destiny Laboratory of the International Space Station. Followed by Expedition 6 Commander Ken Bowersox entering his new home for the next 5 months. Nikolai Budarin right behind him. The two Russian cosmonauts embracing. The oncoming and offgoing expedition commanders talking to one another, Valery Korzun and Ken Bowersox.
Coffee. Thank you.
Congratulations.
And Don Pettit entering the International Space Station.
Everybody here? Hello. Anyway, look what I said.
This is Mission Control Houston with the initial greeting by the shuttle and station crews now having been completed. We've lost our downlink television signal from the station. However, this is television from the shuttle payload bay cameras looking right up at the Destiny laboratory of the International Space Station. On the far right of your screen is the Starboard 1 or S1 truss segment that was installed on the station last month by Atlantis' astronauts, soon to be joined on the left side of your screen tomorrow by the P1 or Port 1 truss segment. Just above all that is the Quest airlock on the upper right-hand portion of your screen, the airlock from which Mike Lopez Alegria and John Harrington will begin the first of 3 spacewalks tomorrow afternoon to help activate and install the P1 truss. This is Mission Control Houston. Expedition 6 Commander Ken Bowersox carrying the first of the bags containing the Soyuz seat liners that are in the process of now being transferred from Endeavour to the International Space Station. You saw right before Bowersox some of the components of the spacesuits to be worn by Mike Lopez Alegria and John Harrington for their first spacewalk tomorrow, being transferred from the shuttle into the station as well. So transfer activities and expedition handover activities are now well underway, with the opening of the hatches and the initial greeting between the crews having been completed.
Good evening and welcome to today's STS-113 mission status briefing. With us this evening is Paul Dye, STS-113 lead flight director. Paul?
Thank you, John Arrow. Just say a few words to start. It was a very successful docking today. I would say it was a textbook rendezvous. It was very, very smooth all the way through. I was very pleased to see Jim Weatherby flying again. I've done a number of missions with him, and he came right down the pike. All the docking parameters were just excellent. It was just like the thing was designed. The docking mechanism today worked perfectly. I think we're really learning how to operate that after these years. It was absolutely flawless. It was the quickest from contact to a hard mate that I think I've seen. All the items on the timeline had been completed when I left the control center. The docking was a little bit late, but that's just because they were being nice and smooth on the approach. They caught things up very quickly, and we're pretty happy now to turn the center of attention over to the ISS side of the house for the next week or so, while they take the P1 out of our bay and install it, and we do a number of EVAs to make things ready, and at the same time hand the crews over. And I thought it was really wonderful to see all three crews, the Expedition 5, Expedition 6, and the STS-113 orbiter crew together in the ISS there before we left. For people who are looking for numbers, the docking time was at 3:59 p.m. Central Standard Time. We opened the hatch about 5:31 Central Standard Time. That's all I had prepared, so I'll take any questions that people might have.
Okay, we'll begin this evening with questions from the Kennedy Space Center. Please remember to state your name and your affiliation.
This is Marcia Dunn of the Associated Press. As I was walking over here, I think I heard the commentator say that tomorrow's spacewalk would be conducted out of the Shuttle middeck and not Quest. Is that so, and could you talk about that, please?
No, the EVA will be conducted out of the station. There's some discussion right now that we're having a problem with the exercise bike on the station, the CVIS. And as you know, Marcia, the pre-breathe protocol for EVA these days requires that they do a certain amount of exercise while breathing oxygen up front. So we're probably going to be using the shuttle bicycle or ergometer for that exercise in the morning, and they were just working on that, getting started working on that plan as I left. So the EVA is going to be conducted out of Quest, but we may do some of the prep over on the shuttle side.
Great, thanks for clearing that up. And I'm wondering if there's any more word on the OMS engine problem that occurred during liftoff?
There really isn't anything new about that because we haven't used the engine. We didn't need to use the engine. All of the OMS burns that we need to do prior to deorbit, the deorbit burn have been completed now. So we don't have any more big OMS burns. We got through all of them with the left engine just fine, and we'll take a look at that ball valve when we get back, and we can use that engine for deorbit. We are allowed to use it once, and we probably will. And then we get back, we'll take a look at it. I think there's suspicion that it's instrumentation, and it really didn't interrupt our plans in any way.
Thanks. And another question from me. Because you had a scrub Friday night, I'm wondering what your propellant situation is, and if you think you might want to squeeze an extra day into the docked phase, and whether you could do that.
Propellant is tight as always, but we docked with about the margins we expected to dock with. The question is more one of cryo. And the cryo situation is quite good. I think we had, when I came on this morning, we had our nominal mission plus 1 day, plus another 20, 22 hours, plus our extension days. So the mission was planned for 11 plus 1 with 2 extension days, and we may have an extra day above that if we need it.
Now, this is Peter King with CBS News Radio, and I want to look ahead to tomorrow because, excuse me, we have a delicate maneuver involving P1, 2 robot arms that may or may not be a little bit tricky, or is there in your eyes anything really tricky about it, or is it pretty straightforward?
I think anytime you're handling a mass that large with 2 arms, it's going to get your interest. Would I say it's particularly tricky? Not really. It's all well understood maneuvers with good clearances. The crew has practiced it many times, and I am planning on watching a fairly nominal operation tomorrow. So there's nothing particularly tricky about it, but it will keep all of our attention.
And this is Kelly Young at Florida Today. I was wondering if there was a particular reason that you choose to use the ergometer rather than the treadmill for the pre-breathing.
To tell you the truth, the protocols, I believe, are designed to be used with the bicycle, and they have a method of, or they have an understanding of the exercise protocols to be used with that. That situation developed just as I was leaving the control center, so I really didn't have a lot of time to look into it, but I think the basic reason is similarity with what we were going to do on the station.
And one more for me, was moving this exercise over to the shuttle, will it present any logistical issues? I mean, are those masks that they wear completely portable, or are they hooked up to oxygen lines?
They are hooked up to oxygen lines, and they are portable because they're just simple drag-through lines. And to be honest, most of the oxygen is coming from the shuttle anyway, so we'll just loop the lines back that way. So it really shouldn't present much of a difficulty. We'll obviously update the checklist and make sure that we iron out all the wrinkles, make sure that there's nothing hidden in there that could surprise us. And I expect we'll have a pretty straightforward plan for the crew in the morning.
Yes, this is Marcia Dunn with another question. I wanted to ask you about the snag yesterday with the shuttle robot arm and the wrist roll joint. I understand that it could have been debris in the gearbox instead of the lubricant issue, and I'm wondering what's the latest thinking and how that might affect tomorrow when you go to grab the truss.
Well, obviously, until you get it back, you can't tell exactly what was in there, but what we saw, Marcia, was a very, very minor jerkiness in the rate of the wrist roll the first time we used it, or early on in the process. And as we tested it out and used it and rotated just that joint a few times back and forth, that jerkiness went away. That's why people were thinking that it was lubricant that just needed to kind of get spread out among the gears. Could it be FOD? Yes. But most likely the problem is taking care of itself, at least that's the way it looked, and so I don't really anticipate any problems tomorrow. I think that whatever was in the way, whether it was a lump of lubricant or something else, has been smoothed out and taken out of the way. So I'm anticipating smooth operation with the wrist tomorrow.
So you didn't need to change the details for that tomorrow at all?
No, we didn't do anything. As a matter of fact, we're happy with the arm the way we used it since before we put it away, we had several good operations of the wrist roll before after we had the very minor anomaly. We think that was a good test, and we're expecting it to be straightforward tomorrow.
I believe that was the last question from Kennedy Space Center, and seeing no questions from other centers, that will conclude today's program.
Die US-Raumfähre Endeavour hat an die internationale Raumstation ISS angedockt, mit an Bord die neue Besatzung. 2 Amerikaner und ein Russe lösen die alte Crew ab, die nach mehr als 4 Monaten zur Erde zurückkehrt. Die dringlichste Aufgabe der Astronauten, sie sollen ein 14 Tonnen schweres Gerüstteil an der Raumstation anbringen.
Endeavour Houston, good morning. Bone, that was Give Me All Your Lovin' by ZZ Top from Debbie and the Girls. Today they'll be wishing you lots of luck and lots of love as you take your first spacewalk today.
Morning, Houston. I'm feeling the love. That's great. Thank you very much. Gets the heart beating in the morning. Thank you.
You are quite welcome.
P1 is installed the morning of EVA 1 while the crew is inside getting in their suits. On the left in the shot here, you can see P1 already installed. The first task is the Nader utility tray mate, which is required to provide keep-alive power to various P1 components. Mike will be doing this task from a foot restraint where he'll mate harnesses from S0 to P1. While Mike is mating those connectors, John will begin working on the Crew Equipment Translation Aid Cart, or CETA cart. The CETA cart is basically a work platform that can be used to translate hardware and ORUs up and down the truss. There's one CETA cart already on orbit. It was launched up on the S1 during the 9A mission, and that's called CETA cart number 1. This is CETA cart number 2. John releases 4 launch locks that bolt the CETA cart to the truss, and then he releases launch locks on the brake handles, and the brakes are used to slow and stop the CETA cart. Next, Mike will install SPDs on the flexible hose rotary coupler, or FHRC, fluid lines, which run in between the truss and the radiators. He'll actually be working inside the truss to install 6 of the 1.5-inch SPDs. John and Mike will then work together to remove the drag link. For launch, the drag link stabilizes the keel pin, which is used to support the P1 truss while it's in the orbiter's payload bay. We have to remove both the drag links and the keel pins in order to allow the CETA cart and the MT to translate onto P1. After they remove the drag link, they stow it in a bracket on the exterior of the truss. We repeat the same removal and stow procedure for the port drag link. Here in this side view, you can see how the drag link is attached to the keel pin as well as to the truss. Next, Mike will mate the last and final set of electrical connections, again from S0 to P1. After these connections are mated, then all of the components on P1 will have the required keep-alive power. The last task is installation of the Node Wireless Video System Antenna, or WETA. The WETA is an antenna that works with the helmet cameras that the EV crew members wear. After we get these antennas installed, then station EVAs without the shuttle present will have the capability for wireless video from the helmet cameras. The first part of the task is removing a stanchion from the keel pin. The crew will then take that stanchion to the airlock where the WETA was stored at the beginning of the EVA. There they'll attach the WETA to the stanchion. Then Mike will take that entire assembly to the aft part of the node. He'll bolt it in place, and then he'll mate 3 electrical connectors and remove the thermal cover.
This is Mission Control Houston. You're looking at live video of the Space Shuttle Endeavour docked to the International Space Station. Endeavour and the station currently flying over northeastern South Africa, continuing on a northeasterly trek that will take them over the Indian Ocean.
You can see a good view here of the P1 truss having been removed from the payload bay and placed in the correct orientation. It's known as the arc orientation prior to its being maneuvered for a handoff to the station's robotic arm under the control of Peggy Whitson from the robotic workstation in the Destiny laboratory. So the P1 truss is out of Endeavour's bay and is firmly in the grasp of the shuttle's robotic arm, ready for a handoff to the station's robotic arm a short time from now. Spacewalk choreographer Paul Lockhart confirming that the initial phase of the pre-breathe protocol for Mike Lopez Alegria and John Harrington has been successfully completed, breathing pure oxygen through an oxygen mask while bicycling on a shuttle ergometer machine mounted on the middeck of the shuttle Endeavour. So with that pre-breathe protocol having been completed, the 2 spacewalkers continuing to wear oxygen masks will now make their way back over onto the International Space Station side of the complex to make their way into the equipment lock and begin the process of suiting up while the P1 installation process continues. As you can see in this downlink television, the truss has been maneuvered to the handoff position. We are awaiting the movement of the station's Canadarm2 robotic arm by Peggy Whitson to begin to move towards a second grapple fixture on the truss to take a handoff from Commander Jim Weatherby, who has a firm grasp on the 14-ton truss segment through the shuttle's robotic arm. Everything going very smoothly so far in the early stages of today's activity. This is the busiest day of the mission, with not only the truss installation, which involves delicate robotics handoff operations, the mechanical bolting of the truss once it is aligned for capture onto the port side of the S0 truss. There are 4 mechanized bolts that will drive the 2 truss segments together. At least 3 of those bolts must be fully engaged to satisfy the requirements for a firm structural mate between the 2 truss segments. A good view of the 45-foot-long Port 1 truss segment firmly in the grasp of the Shuttle's 50-foot-long Canadian-built robotic arm, being maneuvered into a position for a handoff to the Canadarm2, the station's robotic arm, which is being controlled by Peggy Whitson from a robotic workstation in the Destiny laboratory. Endeavour and the International Space Station have now passed into daylight over the Pacific Ocean, traveling at an altitude of 248 statute miles. Truss segment, you can see the 3 boxy-like devices mounted on the top side of the P1 truss. Those are the 3 large radiators that are folded up. Once unfurled, they reach a distance of about 70 feet in length, all providing cooling for the various avionics of the International Space Station. These radiators will remain folded up after the P1 truss is installed. Only one of the 3 radiators on the P1's twin, the S1 truss, was unfurled during the STS-113 mission a month and a half ago. This view of the Port 1 truss segment high over the payload bay of Endeavour. On the right side of your screen, the Destiny laboratory of the International Space Station. Inside Destiny, Peggy Whitson is at the robotics workstation, operating the Canadarm2, preparing to maneuver the station's robotic arm into a position to take a handoff of that truss from Commander Jim Weatherby, who's operating the shuttle arm from the aft flight deck of Endeavour. In the upper right-hand portion of your screen, you see the Quest airlock, the airlock from which Mike Lopez Alegria and John Harrington will begin the first of 3 spacewalks this afternoon to assist in the installation and activation of that truss segment. Complements of the sequential still video system through the S-band communication system on Endeavour, the shuttle's robotic arm having ungrappled from the P1 or Port 1 truss. It is firmly in the grasp of the station's robotic arm. You can see on the face of the Port 1 truss to the left side of your screen the capture bar that will be installed on the capture claw on the port side of the S0 truss. These 3 boxy-looking devices at the very top side of the Port 1 truss are the folded radiators that ultimately will be unfurled to provide cooling for the station's avionics, just as they will on the starboard 1 truss segment, the twin of this truss on the other side of the S0. At the very end of the Port 1 truss, in the foreground of one of the large solar arrays, you saw the ammonia tank assembly, which houses 600 pounds of ammonia to provide the cooling for that truss segment.
Houston Endeavour, this is Alpha. We're starting motion on the P1. Going to move to pre-install position.
You copy, maneuvering to the pre-install position.
This breathtaking view from payload bay cameras on Endeavour, showing the magnitude of the truss segments with the huge U.S. solar arrays in the background on the P6 truss segment that is mounted to the Z1 truss on the International Space Station. Mike Massimino, the station Capcom over in the Space Station Flight Control Room, confirming that the Port 1 truss is once again in motion as Peggy Whitson maneuvers the huge 45-foot-long truss segment for its final installation onto the port side of the S0 truss, which is on the right side of your picture. The robotic systems officer in the space station flight control room reports that the Port 1 truss is now in the pre-installed position, just about 3 or so feet away from being captured by the capture claw on the S0 truss on the right side of your screen as we continue to take downlink television from Endeavour's payload bay cameras. The two spacecraft are flying over the Pacific Ocean at an altitude of 248 statute miles, everything going very smoothly in the Port 1 truss segment installation procedures today. This is Mission Control Houston as Endeavour and the International Space Station pass over the South Pacific at an altitude of 246 statute miles. Work continues to precisely align the P1 truss segment, the Port 1 truss segment at the top of your screen with the S0 truss segment, which now is in the lower left-hand portion of your screen. You can see the capture claw very clearly on the port side of the S0 truss that will latch onto a capture bar on the Port 1 truss to form the initial installation and capture of the two truss segments, then allowing 4 motorized bolt assemblies to begin to engage to form a permanent structural mate between the two trusses. Expedition 6 Commander Ken Bowersox now indicating.
We're moving in to the RTL.
Ken Bowersox now indicating that with the alignment of the two truss segments complete, he and Peggy Whitson are ready to continue the maneuver of the Port 1 truss to the so-called RTL or ready to latch position, placing the two truss segments just about 3 inches apart from one another. Once the two truss segments come into contact with one another, there is a two-stage process to enable the capture claw on the S0 truss to wrap itself around the capture bar on the Port 1 truss. The station robotic arm will be placed in the so-called limp mode, ensuring that there is no uncommanded motion of the arm during the time of the claw and capture bar latching process prior to the start of the initialization of the bolting, the motorized bolt work that will structurally mate the two truss segments together.
On the big loop, we got 3 RTLs.
We copy and concur. Great work.
Yes, RTL 3 first, then 2, and Peggy gave it a little bit of yaw to get number 1.
We were watching. You got a happy control room down here.
This view from television cameras aboard Endeavour showing the structurally mated truss segments, the Port 1 truss on the top, the S0 truss on the bottom. Those two truss segments now permanently mated to one another, setting the stage for the 6.5-hour spacewalk about to begin by Mike Lopez Alegria and John Harrington. This downlink television from the International Space Station from a camera that is positioned at the end of the starboard 1 truss segment, 45 feet outboard from the modules of the International Space Station, showing the shuttle Endeavour docked to the forward docking port of the Destiny Laboratory, and on the right side of your screen, the Quest airlock from which Mike Lopez Alegria and John Harrington will be emerging a short time from now. And now a view of the Quest airlock, courtesy of the starboard 1 external camera.
Hello, Paco. LA, I have you loud and clear. Help me. I have you loud and clear. And EV2, I have you loud and clear. Help me. China, I also have you very loud and clear. Oh, you sound wonderful. You, unbelievable.
You can see the outer hatch now open on Quest.
Okay, on my mark, I need you to take your power switch to the battery position. This will be staggered with EV1 first, and I'll record the times. Are you ready? EV1's ready. EV2's ready. Okay, on my mark, 3, 2, 1, power to battery. And EV2 to battery.
And and Lopez Alegria and Harrington have now placed their suits on internal battery power, marking the official start of today's spacewalk at 1:49 p.m. Central Time as Endeavour and the International Space Station approach the west coast of South America.
Hey, Paco, let me know when you've got the checklist out.
And Mike Lopez Alegria now emerging from the outer hatch on the crew lock of the Quest airlock. The spacewalk again officially began at 1:49 p.m. Central Time as the crew members Lopez Alegria and John Harrington placed their suits on internal battery power.
Sounds good, John. Holy mackerel. Verify my hook lock. Closing the thermal cover.
John Harrington on the left, Mike Lopez Alegria on the right, working on their respective tasks. Harrington involved in the initial phase of all of the launch restraint releasing work associated with that handrail cart on the P1 truss. Mike Lopez Alegria on the right working to hook up a series of cables between the S0 and P1 truss segments.
I just saw you standing there. I thought I might take a picture of you. What do you think? Go ahead. Why don't you do some work so your family won't think you're goofing off up here on vacation? Oh, how true. If they're out there watching, hi. Okay, I'm going to go up and around. Okay, John? Okay, TLA. 255 MET, thanks.
Good copy.
Did you want to, for this next task, relocate your camera to the mini workstation swing arm? Not right now. I've already taken the kill pin. The kill pin.
This view from the LA cam shows Lopez Alegria using his pistol grip tool, essentially a cordless drill with a socket set, to install that drag link into its storage location on the truss structure.
10.5 turns. Okay. Hey, Paco, that guy looks good. He's clean. Okay, we have it. Thank you.
Spacewalker Mike Lopez Alegria adapting to the situation on orbit, snaking that cable through a nest of other cables that was in a position that had not been anticipated behind some other cables. He had to kind of wind it out of the other cable's way so he could get it to its proper connector. That connection now made as he continues to step through these connections of power and data cables that will route power and data between the S0 and the P1 truss structure.
P14 has made it to gate 14. Pins look good and they look clean. It is not yet made it.
Copy that, LA. And John, do you want me to read you the steps A1 and B?
You have no idea what they are, Don. Thank you. Going to the starboard swing arm, you said? That's correct. The starboard swing arm with a yaw pitch of 3 kilo. Thank you.
wait there, I'll help you. Can you keep coming? I'm going to ask you, hold it right there. You take my hand. I got you. You're clear. I'll pull you around. Look, stand by. Thank you. Okay, watch my head. Hold it. You clear my head, clear? Okay, you're clear. Okay. Thank you, guys. Yeah.
This is Mission Control Houston. We're receiving downlink television pictures from the International Space Station as we look at spacewalker John Harrington getting an early start on the cleanup activities for the end of the spacewalk. As we can see Mike Lopez Alegria behind the doghouse nitrogen and oxygen storage tanks around the exterior of the Quest airlock module, finishing up the cable connections for the wireless video system external transceiver assemblies, or WETA, that he and Harrington have just assembled and put in place on the outside of the Unity module.
I see him. Stand by.
We copy you, and the WETA heater activation is in work. Just a couple words for you, Paco. The ground team is happy to leave the stanchion bolt in its current position for overnight. We may come look at it later.
Okay. Thanks, Barbara.
There you go. Go your feet to your
Alpha Houston.
right. Am I right? You're right. There you go. Okay. Yeah. Your safer's in. Go a little more vertical if you can.
Alpha Houston for EVA for Paco Step 1 is complete.
Thank you.
Good job, LA. Not done yet. The hard part. That great big thing. That is our ball bags. Anyway, I think so. That's hacking to them. Hey, Bob, before we sign off, I want to say thank you and the whole flight control team, especially Dana and Karina and Brian, for a great job today.
Thanks for the great words, and you guys did a fabulous job today. We appreciate your hard work. You make us all proud.
We wish you guys could all be here with us, but then there'd be nothing for us to do.
Oh, we could find something for you to do. We'd be glad to be up there with you.
Yeah, like S1 FHRCs. And
Yeah, exactly.
Also for helping out with all the EMU stuff.
Just to let you know, we're really disappointed you didn't want to go out, excuse me, and do those S1 FHRCs today.
I was thinking about it.
Good evening and welcome to today's STS-113 mission status briefing. With us this evening are, from my right, Kim Ulrich, STS-113 Launch Package Manager. Next is Bob Castle, STS-113 Mission Operations Director. And on the far right is Dana Weigel, STS-113 Lead EVA Officer. Kim, would you begin, please?
Yes. Good evening and welcome to the 11A mission status briefing. We've had a very successful mission thus far. It's progressing extremely well. We've completed our top 2 mission objectives. We've got the Expedition 6 crew on orbit and their safety critical hardware is transferred across the hatch. We had a very successful installation of the P1 truss today. We couldn't have asked for a better day. The installation procedure went extremely smooth. Both of our robotic arms operated nominally, and the P1 truss hardware in particular, the segment-to-segment attach system functioned as designed. I'd like to take this opportunity to thank the 11A flight ops team. We had a very good team. I think we did a really good job today, and they once again made a very complex task look simple. I'd also like to congratulate all the personnel that worked on the P1 truss across the country, both the NASA design centers and the Boeing design centers. All their hard work paid off, and we had a very good day. So with that, I'll hand it over to Bob.
Well, thank you, Kim. I appreciate the compliments. Folks have worked very hard. Again, today things went very, very well. The highlight of today, in my mind, really was an installation of the P1 truss segment. And then EVA-1, the primary purpose of which was to hook up all the power to bring P1 alive. And then we activated P1. All of those systems came up. Everything has come up beautifully. All the hardware is working. There are no anomalies to talk about at all on it. With the activation of the P1 truss, we now have completed what I think of as the center part of the truss segment. We now have all the entire cooling system. All the radiators are on orbit. All the cooling lines are all there. The ammonia and the coolant is all there. So the air conditioning system, if you will, is now fully constructed and is ready to be turned on. So we're ready for the next stage of assembly, which will be the 12A, 113A string of missions, which will be bringing up 2 new power channels, as well as turning on the air conditioning system that will cool the rest of the station. So that's in line for us early next year. The shuttle is continuing to perform very, very well. There are no anomalies to speak of. You've heard about the ones that happened during launch phase, which are no issue at all, and will be no mission impact. We currently have extension days available if we should need them, but quite frankly, so far I don't think we will. Excuse me. Looking ahead a little bit, what you can look forward to for the rest of this mission, Wednesday will be finishing transfers, both equipment and finishing some of the stuff that needed for the Expedition 6 crew. We'll also be doing the first of our 3 reboosts on Wednesday. These are reboosts done by the shuttle to raise the station altitude. Thursday, Thanksgiving Day, will be EVA number 2. And then Friday, we'll have another day of mainly transfer work, handovers, and reboost, followed by Saturday's EVA number 3. And then we'll finish up on Sunday with finishing up the last little bit of transfers, handover work, a little bit of maintenance work we'll be doing on Sunday, and as well as some off-duty time for the crew. They will have worked very, very hard by the time to get there. We'll be undocking on Monday, and then if weather cooperates, we'll be landing Wednesday at the Kennedy Space Center, where the last number I had was 2:49 p.m. Central Standard Time. With that, I'll hand it over to Dana, who can talk about the details of the EVA today, and certainly if there are any questions about the future EVA, she's better qualified to answer than I am. So, Dana.
Thanks, Bob. As folks have mentioned, today's EVA was very smooth. The crew and the ground team both did an excellent job keeping the timeline marching along. It was a 6:45 EVA, and just to summarize what we did today during the EVA, the crew hooked up all of the power and data lines between F0 and P1. They also installed 6 of the 1.5-inch full positioning devices which go on the fluid quick disconnect lines. They released all of the seat-of-cart launch locks and removed 2 drag links, and then they finished up with installation of a Node wireless video system antenna. And that summarized all the tasks we did during the EVA. That's all I really have for a summary. I'll hand it back.
Okay, thank you very much. We'll take questions now. We'll start with reporters here in Houston. Please don't forget to say your name and your affiliation before your question. Mark, would you start?
Thank you, Mark Carreau from Houston Chronicle. I have probably kind of a background question, but is there time set aside for repairs to the carbon dioxide units in the U.S. and Russian sides? Is that either going on now or planned during the shuttle visit?
Okay, at least I'll take a stab. Yes, it is planned. We do have spare parts that were brought up on this flight for SEGRA, the carbon dioxide removal assembly. It isn't in the timeline, I think, officially yet, but it's going to wind up in there on flight day 9 as one of the final things we did. As far as maintenance on the Russian segment, there's already been some maintenance done on that one. They've replaced several parts, and I think they're pretty much done with their work in the near future. We want to go ahead. SEGRA is currently operating. It continues to intermittently have a valve that fails to move right and shut itself down. We've always been very successful at starting it, but it requires a fair amount of care and feeding to restart it and keep it going. But since it is working, we're not using any consumables of lithium hydroxide, so we're going to wait till flight day 9 when most of the mission is behind us to take it apart and hopefully fix it.
Okay, thank you very much. And that's probably for Dana Wagle. The arm seemed to operate without any difficulties today on the shuttle side, but I just wondered if there was anything at all that you would attach to the impact it's sustained during the countdown.
Probably, yeah.
No, the impact did not do any significant damage to the shoulder of the arm, and if there had been anything, we wouldn't have noticed it as a structural member. We also had a small problem with the wrist roll joint you may have heard about early on. That appears to be a transient. It is completely gone. So no, we noticed no abnormal operation of the RMS at all, and no impacts from the impact by the platform pre-launch, nor do I think we could have noticed any impacts. If there had been anything for us to see, we wouldn't have launched.
I believe that's all the questions here at Johnson Space Center. We'll move now to reporters at Kennedy Space Center.
Hi, this is Chris Kreidler from Florida today. Bill Harwood's going to ask my serious question, so I'm going to ask a silly one. I know turkey's not the first thing on your mind, but do you know if the crew has a Thanksgiving dinner of some sort planned?
I honestly don't know. Certainly they knew when they launched they were going to be in orbit during Thanksgiving, so I'd be surprised if they didn't have something planned. I don't know precisely what. Since Thanksgiving Day is going to be an EVA day, that's going to be a very, very busy day for them. So I suspect they'll celebrate Thanksgiving on some day other than actually Thursday, but I suspect they have something.
This is Marcia Dunn of the Associated Press for Dana. Do you know the total number of power and data cables that were actually hooked up today?
I think we had around 7 on one of the trays and 9 on the other, so we had about 16 cables we connected today.
Thanks. And I'm wondering, I heard at the very end where the biomedical data had some trouble. What went wrong, and is it risky to have an astronaut on a spacewalk if his biomedical data isn't coming back down to Earth?
Well, we don't know what went wrong. We actually lost it early on in EVA, which is pretty common. There's a lot of different places where we can have errors, one of which is we don't have good skin contact when they put the biomed patch on themselves. That's one of the most common problems. We don't have a requirement to have biomed data. That's a nice to have. We do have other data that we can track on the ground. We can see their metabolic rates by looking at their O2 consumption, so it's not required to have it.
Bill Harwood with CBS with a couple of quick ones. I'm just wondering, the problem they have with the station exercise equipment, won't that affect the stage EVAs that are coming up? How do you do your pre-breathe and all of that stuff if the shuttle is not there and if that exercise thing isn't working?
Well, we're looking at that right now. There's a team off trying to decide what to do. There's a couple different options they're pursuing. Bob, you may have more details, but one is still to look at the CVIS to see if there's any way to fix it, and some other things in discussion are possibly talking about taking the shuttle's ergometer and transferring that over to station to use that for the stage EVA.
Yeah, I guess I'd add a couple of things there. We're looking at repairing CVIS. We think there's still very much an option to repair it. We think potentially we could use it as is. It's stuck in the manual mode is what happens. Well, you can still load the crew and do an exercise in the manual mode. The question is, can you do it precisely enough to match the protocol that our surgeons have worked out for getting nitrogen out of the bloodstream? Other than that, there are alternate pre-breathe protocols that are available that we've used on the shuttle for years. We can take the airlock down to 10.2 psi with 2 guys in it for an overnight period, which is referred to as camp out. Do the same type pre-breathe we do on the shuttle. We could also do an in-suit pre-breathe. So I guess, Bill, in answer to your question, yes, if we don't get it working right, it is going to impact the stage EVA. I don't know that it's going to mean we can't do a stage EVA. It means we'll have to do something a little different.
Okay, thanks. Yeah, I thought camp out was an option. I didn't realize that suits was. And the big question burning in all of our minds here is a question for Dana, and it's utterly on the trivial side, but none of us understand when the commentator says it started at 2:49 today and ended at 9:35 Eastern Time, that works out to 6:45, because it doesn't. It works out to 6:46. And our readers think we are stupid. So you guys obviously realize the EVA actually went 6:45 and 53 seconds, and for the life of me as an old physics major, I cannot understand why anybody would round 53 seconds down to 0. So I'm hoping you can explain why you round down.
We didn't. We just had this discussion before. The reason why we started rounding down the times is that our EVA clock technically stops when we start repress. And it's difficult to tell exactly when the crew starts repressing the airlock. The data on the ground doesn't always respond right away. So what we do is we watch the data, and as soon as we think it starts to change, and indeed the repress, we stop our clock. And oftentimes that's 30 seconds or so off. So we tend to round down. That's where the rounding came from.
That's cool. Well, do you think maybe somebody would go back and let's just say this thing ended at 8:34 tonight Central Time so people don't think that we simply can't add? I mean, I'm serious. I realize it's trivial to you guys, but I'm serious about that. What do you think?
I think we'll leave that to our public affairs as to exactly what numbers they should be reporting it.
Okay.
Peter King with CBS News. I don't know how to follow that one up, but Dana, if you would, a quick look ahead to what we'll be seeing on EVA-2, please.
Sure. The main tasks for EVA-2 are installing 2 fluid jumpers. Those will go between S0 and P1, and we'll be installing some spool positioning devices on those jumpers also. We'll be removing both of the keel pins, and that's to allow the CETA cart and the MT to be able to translate out onto the truss. We'll be installing another wireless video system, and that'll be at the very end of P1. And the last task of the EVA will be relocating the CETA cart. After we relocate the CETA cart, that sets us up for the beginning of EVA-3 and actually allows the MT to come all the way down to the end of P1 for EVA-3.
In your best layman's terms, can you explain what the fluid jumpers do?
Sure. The fluid jumpers will be responsible for carrying ammonia between S0 and P1. They're part of the cooling system. Right now, they're on S0. They were launched with 8A, and they have nitrogen in them. So the cooling system won't be activated until 12A.1. So for right now, they actually won't be doing anything. But when we fill the truss on 12A.1, they'll carry ammonia back and forth between the radiators, which are out on P1, and the main part of the station.
And I guess this is the last question from here. Oh, I'm sorry, there's one more. Spoke too soon. Barbara Morgan was kidding when she was talking about doing some get-ahead tasks at the end there, right?
She was kidding. She was kind of harassing Mike because when he got done with installing the spool positioning devices on the FHRC, the flexible hose rotary coupler, he kind of said something like, oh, I hope I don't have to see another one of those again for a while, because it was pretty tough. Well, he does have to do that task again on EVA-3, and he knows he has to do that, so she jokingly said, hey, would you like to go do that right now?
This is Marcia Dunn with the AP with another question for Dana. Do you have any reason, do you have any reason to think why John Harrington's oxygen ran a little low? Why did he need a refill when Agolo Casalagria didn't?
Each person is different, and it depends upon their metabolic rates, and it also depends upon their activity level. John was doing a lot of maneuvering larger items around, moving a tool bag around, scurrying around a lot, which tends to raise your met rate. So that's not expected. He was within the ballpark of what we've seen for other crew members with that type of activity.
I believe that was the last question from Kennedy Space Center. Do we have any follows here in Houston? Seeing none, we'll conclude the briefing. Thank you very much for coming.
2 Astronauten der Internationalen Raumstation ISS haben einen Weltraumspaziergang erfolgreich beendet. Die Amerikaner befestigten an der Außenwand der Station eine Trägerkonstruktion für Solarflügel und Antennen. Mithilfe von Roboterarmen installierten sie das 14 Tonnen schwere Bauteil. Die beiden Astronauten waren 7 Stunden lang im Einsatz.
Nur wenige Stunden nach ihrer Ankunft an der internationalen Raumstation ISS haben 2 Astronauten der US-Raumfähre Endeavour ein neues Trägerteil für die Station installiert. Die beiden Raumfahrer arbeiteten insgesamt 7 Stunden außerhalb der ISS. Am Donnerstag und am Samstag stehen ihnen weitere Außenbordeinsätze bevor.
44 minutes from now, Commander Jim Weatherby will initiate the first of 3 scheduled reboosts of the International Space Station using the shuttle's reaction control system steering jets to increase the altitude of the station in a stair-step fashion. This will be about a 45-minute reboost today, changing the velocity of Endeavour by about 8.5 feet per second, increasing the station's altitude by about 2 nautical miles in the process. Again, the first of 3 such reboosts planned for this mission, that coming up in about an hour and 44 minutes from now. But again, this is a day that will be, in contrast to yesterday, a day of relatively light communications on the air-to-ground and space-to-ground communications loops from both the shuttle and the International Space Station as the crews get down to the transfer work involved, transferring again all of the critical items for the Expedition 6 crew that were brought on board Endeavour and up to the International Space Station, as well as the handover time that is ever so precious between the off-going Expedition 5 crew and the oncoming Expedition 6 crew to properly prepare the Expedition 6 crew for life and work on orbit.
Here's a view inside the Destiny Laboratory. Peggy Whitson in the right, Paul Lockhart coming head on, and this is a look at Mike Lopez Alegria and John Harrington as they work on their the helmets of their spacesuits that they'll use tomorrow, putting on some anti-fog on the inside of those helmets. It's a little hard to clean the inside of them once you get them on and get outside the spacecraft, and so they take a very careful approach to applying this. Here inside the Destiny Laboratory, Ken Bowersox, the new commander of the International Space Station, in the foreground, with Peggy Whitson, the first International Space Station science officer, in the background in the green shirt. Expedition 5 Commander Valery Corzone with his back to us in the turquoise shirt. And now Whitson and Bowersox get to work on the work inside behind the module to replace those valves in the carbon dioxide removal assembly. As Nikolai Budarin has an opportunity to use one of the communications channels inside the Unity module of the International Space Station. This is what's known as the IP phone. It uses internet-type protocols to work as a basic normal telephone for the crew members on orbit. And this will look inside the flight deck of the Space Shuttle Endeavour. And taking the digital TV camera equipment back down inside the mid-deck. We can see here the bicycle ergometer that was used to do the pre-breathe procedure for the first spacewalk. It looks like that bicycle ergometer will need to be used for the next 2 spacewalks as well at this point. And this is the pathway that astronauts take when they leave the space shuttle and move up into the International Space Station. This is a look inside the Quest airlock module where John Harrington continues to work on his spacesuit equipment for tomorrow. And this view through the pressurized MIG adapter number 1 that connects the Unity module to the Zarya control module, the Russian segment of the space station. Those white bags are crew transfer bags that are used to hold and corral all the equipment supplies on the space station, stored in many different locations. Now we're into the Zarya control module where you can see the floor is just covered with bags of supplies and equipment, bungee corded down so that they are out of the way for crew members who are moving between modules of the space station. Now moving through the docking port of this Zvezda service module and into the service module. Taking a look down at the entry into the docking port where the Soyuz crew return vehicle is stored. And now into the service module, which is the primary living quarters for the space station crew, where Valery Korzun and Sergei Treshov are making final preparations to pack up and come home. That concludes the replay of the video that was downlinked during the mission status briefing today. Good look at the interior of both the Space Shuttle Endeavour and the International Space Station, with a peek at some of the work that was done on the carbon dioxide removal assembly today. We did get word from Commander Jim Weatherby that he hopes on the next communications pass to downlink some more video of the removal and replacement work for those valves inside the air conditioner system on the station. We'll look forward to more of that video here in the coming hour.
Good evening and welcome to today's STS-113 mission status briefing. With us this evening are, from my right, STS Lead Flight Director Paul Dye. On his right is Kim Ulrich, STS-113 Launch Package Manager. And on the far right is Dr. Jeff Jones, Expedition 5 Lead Crew Surgeon. Paul, would you begin, please?
You bet. Good evening, everybody. Things have been really going smooth on orbit today. The main focus today has been on handover between the Expedition 5 and 6 crews, transfer of items between the shuttle middeck and the station, and of course preparations for EVA-2. I think that one of the reasons everybody was going very smoothly today is because we're all very happy with yesterday's EVA and how well that worked. and I anticipate that tomorrow will be just as successful. The big activity this morning on the shuttle was our reboost of the stack. We raised the orbit by about 2.4 nautical miles, or about 4.4 kilometers. The resulting orbit is 216 nautical miles by 207.6 nautical miles. We used 866 pounds of propellant to do that, and we've got 2 more reboosts planned during the mission. On the station side, they've continued to have a few intermittent Seadra problems, and have decided to go ahead and have Peggy and SOX change out the valves that I know you've heard about with the new ones that we brought up. This should not only restore the Seadra to operation and save us some Lyle cans, but it's a real good handover activity having an upcoming and a downgoing crew member do an IFM together. Peggy's been in on this unit before, and it'll give her a chance to show some of the secrets that she's learned to SOX. That's all I've got. Kim, I'll let you talk more about the station.
Good evening. As Paul mentioned, this has been a very busy day today on orbit. The crew is getting ready for our EVA-2 today, checking out their hardware. Paul also mentioned that on the station side, we had a carbon dioxide removal assembly failure. It has been operating intermittently. We have added that task to today's activities. It should take about 2 hours to replace those 2 valves. We're also getting ready for another full EVA tomorrow. It's about a 6.5-hour EVA. We will be installing F0 to P1 fluid umbilicals, connecting those up, removing our keel pin assemblies. We'll be installing another wireless transceiver assembly, and we're relocating the CETA cart. There has also been some discussions of adding some get-ahead tasks to this EVA, and we'll be working through that today in today's activities. And it is a full transfer day, as Paul mentioned also. We're transferring a lot of cargo over from the shuttle to the ISS. But it has been another successful day, and with that, I'll hand it over to Jeff.
Well, we'd like to give a quick summary of what we have planned for the crew after they return to the ground, and we will begin their science, biologic, and medical science data collection as soon as they return. And then, following this, they have a whole series of medical assessments to see what their current status is, and we will very quickly begin their rehabilitation. When crews go into zero gravity, their body adapts to zero gravity, and they must then readapt to being back on the Earth in the one gravity field. And therefore, we have to condition their body back to that orientation. So we have a whole series of things we do for them from the very beginning, getting them just reoriented to daily living. Things like getting up, sitting down, being able to walk and turn a corner can be an adventure for a crew member when they first return from long-duration flight. So we have to rehabilitate their various systems, their neurovestibular system, their nerves, and their sensing organs. We have to condition their cardiovascular system. And then, most importantly, from long-duration flight, we see losses in their musculoskeletal system, their muscles and their bones. And we have to build their strength and then their endurance back, as well as get the bone mineral density back. And this is one of the areas where we've had the most significant losses in long-duration flight. And we've instituted a series of countermeasures now for both on-orbit and for rehabilitation to restore that function as quickly as possible. So our plan for this Expedition 5 crew is to implement these types of rehabilitation measures. We'll use massage and maybe some physical therapy early on when they first return to the ground to help them to really feel comfortable, because they have some soreness, some muscle soreness, some aches and pains in their joints and their muscles that need to be overcome. Then once their discomfort has been overcome, we must begin to build their muscle strength back, their endurance back, and allow them to begin normal functioning in the one gravity field. Once they return to the Johnson Space Center, we begin to implement more aggressive type rehabilitation measures. We begin hydrotherapy in the pool, and our lead astronaut strength and conditioning rehabilitation personnel. In this case, for Expedition 5, will be Beth Shepard, will be directing most of these types of activities. She will begin to prescribe various exercises, and these exercises will help build the crew members slowly, very slowly over time, until they're more adept to the 1G orientation. And then progressing from that, their endurance will be increased. They'll begin to do more aggressive activities like running until we're finally back to a full flight status, and that takes about 45 days to get through the entire rehabilitation period, at which point in time we can give the crew member back to the flight program to begin training for their next mission. And with that, I'll stop and turn back over to John Adler.
Okay, thank you very much. We'll take questions now, starting here at Johnson Space Center. Please remember to wait for the microphone and state your name and affiliation. Mark?
I'm Mark Carruth from the Houston Chronicle. I had a couple of questions. The first one regards the valves in the carbon dioxide removal unit. Can you sort of explain what these valves do and your best guess as to why they've been difficult to operate recently?
Let me try to answer that question. These valves are called air selector valves, and they direct the flow of air through the system. There are two carbon absorbent beds on the system, and they redirect the flow between those two beds. Some of the theories that are out there are that there could be some particles coming from the absorbent beds themselves and sticking in these valves, and they've just been sluggish, and so hopefully R&Ring them will make the system come back online.
And for Dr. Jones, could you go into a little more detail about how this crew has done as far as exercising? And you have one American and two Russians. Will just Peggy Whitson go through your program here? Do the Russians still have their own program and they separate soon after landing and return to the native country, or how are you working that now?
That's a good question. In terms of how this crew has done on orbit, I'm very proud of this crew. I think that this crew has been very assertive in complying with their exercise prescription. I think this crew has been fortunate in the sense that most of the time we've had functioning countermeasures hardware. We suffered in the previous expeditions from much of our hardware having intermittent failures. We did have some trouble with our treadmill during the flight, but we were able to get around that for the most part. And our resistive exercise device performed the best on this particular expedition that it has in any of the previous ones. And I think that the crew's exercise regimen has really been outstanding. We've come as close as I think we've ever come prior to this in terms of fulfilling the exact protocol, the prescription that we have for the crew. And so I think that this crew is going to do well when they get back. In regards to your question about what happens with the American versus the Russian crew members, they'll be all together for about 14 days post-flight. And so we'll go ahead and initiate their rehabilitation each day. They'll have at least an hour or two each day that they will be doing rehab. They won't necessarily be doing it together, but they'll have a similar protocol for these first 14 days. And then after that, our Russian crew members will go back to Russia, and they have a well-designed program. They go to the sanitarium for their rehab. We keep our crew members here at Johnson, and then they have a whole series of very similar sorts of activities: hydrotherapy, massage, getting them reoriented to their families and to the daily living, the mundane daily living items. And then from there, they'll begin again to rebuild their strength and their endurance.
With no further questions here at Johnson Space Center, we'll move now to Kennedy Space Center.
This is Phil Chen-Earthman for the Polar Chem. What percentage of the carbon dioxide removal right now is being done by the Vozduk, by the Seadra, and by the Shuttle LIHO canisters?
Well, I think right now the Vozduk is doing the majority of work. We have looked at possibly putting a LIHO can in. If we can get this R&R done quickly on today's activities, we won't have to expend the LIHO can if it comes back up and running. So we should be doing well again once that system comes up, if it does.
Okay, so is the Vostok working in the normal 3-person mode or the enhanced 6-person mode in terms of being able to scrub? And is the Seadra doing anything right now, or is it completely down while you're doing the R&R?
The Seadra is not doing anything right now, and I'm not positive the Vostok is in the 3-person or 6-person mode. It may still be in the 3-person mode if we're talking about putting lyocams in.
And is the shuttle being used to help supplement just to move the air back and forth and suck out the CO2 on the shuttle side?
I don't think know
no, we're not doing anything right now. If we're pretty sure that they're going to get the Seadra IFM done in time to the point where we're not going to need to put anything in. If we need to, we'll put in a lyocam and things will be just fine.
And for Dr. Jones, Relays is different from person to person, but can you give us some estimates on how long it's going to take before Peggy can start driving a car again, doing normal, regular activities once she gets back, while she's going through this rehabilitation process?
Well, when we do rehabilitation, part of our program includes periodic assessments of the crew member to see where they are and how quickly they're regaining their 1G functions. And so, as you say, it is variable person to person. Typically, we need to have crew members not fly an aircraft, as an example, for about 30 days after a long-duration flight because it could take that long and maybe even a little longer for their neurovestibular system, their balance organs, and their neural system to regain its 1G function. However, things like normal activities, we expect to be returning between that first and second week, and driving a car will be based on our posture platform and other types of neurovestibular tests, and somewhere within that 2 to 4 week period, I think she would be able to drive a car without any trouble.
Hi, this is Chris Kreidler from Florida Today. A quick follow to that question. How quickly will Peggy be living at home? Does that happen immediately?
Yeah, well, that's the great thing about our program is that we don't have any restrictions from the crew members going home and returning to their family once they get back to Houston. The first couple of days, we'll probably stay there at Kennedy Space Center, and then once we return to Houston, then that night after the medical testing is complete and the other rehab activities, then she'll be able to go home and spend that with her husband, Clarence.
Okay, and about the Russian carbon dioxide scrubber, not to beat it to death, but I know it was malfunctioning at one point. When did it cease to be malfunctioning?
We brought the Vostok back up prior to launch because we did add additional lyocams in preparation for it failing again, but it did come up before we launched 11A.
Okay, great. What is the state of the stationary bicycle on the station?
Well, in regards to, we have 2 bicycles on the station. One is Russian Velo ergometer, which is a hard-mounted unit. The other is what we call the CVIS. It's a cycle ergometer with vibration isolation system. Now, the CVIS had a problem just before we began our pre-brief preparation activities. The day before, Peggy noticed that it was not functioning normally in what's called protocol mode. We can uplink prescriptions to the cycle ergometer and have them automatically execute these prescriptions via the computer that's installed to the bicycle. But in this case, the computer function was not working nominally because it was getting an indication that was in the manual mode where we can manually control the loading. And because of that, we did not use the ISS, the station bicycle, for the pre-breathe. Instead, we used the shuttle ergometer, which was our backup plan. Right now, we've done some preliminary troubleshooting and found out that it may be possible to use the ISS cycle ergometer in this manual mode, and we plan to discuss this actually a little later on with Peggy and ask her to do some testing of this procedure tomorrow during her regular exercise session to see if then it will be capable for supporting the pre-breathe during the stage part of the flight, during the stage part of Expedition 6.
But for now, you'll be using the shuttles for the EVAs?
That's right. We'll continue to use the shuttle ergometer for the next 2 EVAs we have during the docked operations.
Okay, just a couple more. Kim, what would you say the most challenging part of tomorrow's spacewalk is?
Oh, I would probably look at the seat cart relocate being the most challenging one. This is about a 600-pound object that the crew will be holding onto while he's translating on the station arm. So this is going to be a big event tomorrow.
Okay, thanks. And have you all found out any more about what the crew's planning to do for Thanksgiving? Anything special?
Paul, I think you got
an I'm not sure. I have a feeling that they'll probably be doing something special. We looked into the menu food to see what they had for Thanksgiving, and what's listed is actually a fairly international menu based on each of their different choices. But you got to realize that like anybody, they have a fairly large pantry full of food, and I know that there's probably a fair amount of chicken and turkey on board. And just because we have something listed for them on a certain day doesn't mean that that's what they're going to eat that day. So I have a feeling they're probably going to make a feast of it.
This is Marcia Dunn of the Associated Press for Dr. Jones. How many medical assistants are you going to be having with you when you enter the shuttle at touchdown?
Well, on board the CTV, the crew transfer vehicle, we'll have 6 dedicated medical personnel on that vehicle. There'll be 4 physicians and 2 nurses. And the 4 physicians include the lead for the space station, myself, as well as my Russian counterpart. And then there'll be the crew surgeon and deputy crew surgeon for the space shuttle crew. And so all 4 of us will be there, plus 2 of the nurses we have at KSC. So a total of 6 personnel to recover the crew from the orbiter to the CTV.
And will you have the usual stretchers in case they're needed?
Absolutely. We'll plan to have several stretchers on board, and that's pretty nominal operations now for the long-duration crew members to have those available in addition to the recliners that we use for typically short-duration returning crew members.
And do you have any druthers whether they use those stretchers or not from a scientific medical point of view?
Well, our scientists would rather the crew members remain non-ambulatory, means not walking like on a stretcher as long as possible, because many of their science studies they feel are affected. As soon as the crew member begins ambulating and orienting in one gravity, some of their body functions or physiology will change. And so they'd like them to stay down in the microgravity-like posture as long as possible, at least until their experiment is accomplished. So they have those druthers. Obviously, our crew members would like to return to a normal habitus as quickly as possible. We encourage that because we want them to rehabilitate.
And another question for you. You've only had 2 other instances where American women have returned from long flights, and I'm wondering if you're expecting anything different from Peggy's return because she is a woman, and whether you've noticed anything during her exposure to weightlessness that has been different because she's a woman.
I would say Peggy Whitson has been as motivated as any crew member we've ever had in terms of her countermeasures program. And so I expect great things from Peggy when she comes back. And I would say more than likely she'll be as good or in better shape than any of our previous long-duration crew members, regardless of her gender.
But is there any indication from your previous 2 patients that you should expect something different from her because of her gender?
I don't think so. I think that, again, it's hard to say from just 2 previous, so you can't really make any generalizations about only 2 crew members from long-duration flight. But from the standpoint of anything unusual that we will be looking for based on that experience, I don't think that we have anything in this case.
And do you know if the wives, the 2 cosmonauts and their children, will they be on hand for landing, or are they remaining in Russia?
The plan is for them to also come to Florida and be there at the Kennedy Space Center to greet their crew members. And if all goes as planned, then that will be what will happen.
Thanks. And Paul, one quick question for you. If the next 2 spacewalks go as planned, do you see any need to keep the shuttle there any longer than currently planned? I mean, is anybody talking about extra spacewalks to do get-aheads or anything along those lines?
I haven't heard anything yet. So far, if the walks go, if the spacewalks go, the EVAs go just the way we planned, I think that we're fairly comfortable with the mission duration. Of course, there's a number of days between now and then, and so I reserve the right to change that opinion.
This is Phil Chen of Earth News again. I had heard some talk about the possibility of the shuttle people giving the space station people their bicycle because of the issues. Is that still under consideration? If that is done, what would the folks do on the shuttle on the way home for exercise, especially the long duration guys?
You've been working that?
Yeah, I'll be glad if you'd like me to. We would prefer not to do this transfer of the shuttle bike to the station bike, but it is under consideration because we want to make sure we have the necessary equipment to do the exercise pre-breathe protocol for the staged EVA. However, there are some drawbacks from doing that. The shuttle bike is not equipped the same way. It doesn't have the computer controller. It doesn't have the same power source. It doesn't have the vibration isolation attachments, etc. There's a lot of constraints to its use that would be problematic for us. And so that's why we're so eager for Peggy to try out using this manual mode with the ISS bicycle so that we can show that we can do the pre-breathe protocol, the exercise pre-breathe protocol, using the bike and the ISS bike in the manual mode. And once we demonstrate that, we'd like to just leave that in place and let the shuttle take its bicycle back with it. There are some other planned exercise activities we can have the crew members do if they don't have a functioning ergometer. Obviously, power would be a problem on the shuttle, but we can use our expanders, our TheraBands, etc. on the space shuttle for the crew members to exercise with for that short duration of time between the undock and landing.
And I was a little surprised that you were able to use the shuttle bicycle on EVA Day 1, given this lack of vibration, because at the same time, the guys are going through the pre-breathe protocol, you were using the 2 robot arms, and I thought it was no-no to use robot arms while people were exercising because of the vibrations. And I'm wondering how are you able to make everybody happy on that case, and whether or not that might be an issue for the future EVAs.
I can take that one. There are certain restrictions when you're using arms, but it's not all the time, Phil. It's, you know, for instance, we didn't want anybody exercising while we were actually doing the handoff between the two arms. But the arms are fairly robust from the standpoint of minor vibrations, and so there are times when you can do it. And the timing just worked really nice yesterday. The orchestration was really fine. We had no point where we had to stop anybody from doing something because someone else was doing something.
And we were told before launch there were a couple of drill bits put on board for replacing the Arctic freezer, and so wondering when that's going to happen. And the implication with drill bits, I take it, is that you're actually going to physically destroy some screws or something, and in order to get the Arctic freezer that's not working out and take it home on the shuttle?
That's correct. We did launch these drill bits very late in the flow, and the Arctic troubleshooting, we are going to bring an Arctic home. And she will need these drill bits to get them out, and so that is correct.
And I believe that was the last question from Kennedy. Do we have followers here in Houston? Mark?
Mark Carreau from the Houston Chronicle. I had a couple more questions for Dr. Jones. What have you found with the experience so far of 2 years plus on the space station that's the most effective exercise, and how long a day? Are you still kind of in that 1 to 2 hours a day? Are you varying that a little bit? What do you want them doing during this period, however long it is?
Well, we found that you need more than one type of exercise to really complete our countermeasures program. We mentioned earlier there's 3 main systems, and so we target exercise to include all 3 of those systems for maintenance of the crew members' strength and endurance to do EVAs and to be able to do well on reentry to on gravity. And so we use a cycle ergometer, as we mentioned earlier. We use a treadmill, and we use our resistive exercise device, plus a few other types of countermeasures that we employ periodically. The Russians have a loading suit they call the penguin suit, as an example, and they also employ bracelets, small constricting bands that go around the thighs to prevent the upward fluid migration. So we have a number of other countermeasures. There's some oral countermeasures we're testing. In fact, Dr. Woods and I have an experiment on board this flight, and it's been done in the previous flight, looking at a pill to try to prevent kidney stones, which we know may occur associated with the loss of bone mineral. So we target the exercise for all 3 systems. We use the exercises to try to preserve those physiologic systems. We exercise about 2.5 hours a day is allotted for exercise. Now, in that time, not every minute is spent exercising. Some of it is spent setting up equipment, tearing down equipment, getting their clothes changed, and some hygiene in between. But at least 2.5 hours each day is dedicated to our countermeasures program, the majority of which is exercise. In addition, I wanted to mention also our Russian colleagues will often use lower body negative pressure towards the end of the flight as an additional countermeasure to try to get the body used to that gravity vector, bringing the blood down to the feet like happens when you're standing up in one gravity.
And when they return to Earth, can you give a little profile of this 45-day period in terms of how much a day they will spend in physical therapy or rehab, the different programs that you have, and then do you allow them to do office work and debriefing and that sort of thing in conjunction with that, so that they're working a half day or a whole day, or how do you manage that through this 45-day period?
Mm-hmm. Well, it starts out, the first couple of weeks are very intensive in terms of medical and biologic science data collection. So what we see in those first 2 weeks is very intensive schedules. It's managed because we limit the crew day. It's 6 hours of work, and then we have a couple of hours dedicated to rehab during that first 2-week period. The day expands a little bit that second week in terms of amount of work time, but it's mostly filled with data collection. And that second week we also begin to do some debriefs, as you mentioned, and PAO events, things of this nature, once the crew members have rehabilitated to some degree to the one gravity environment. Then after the 2 weeks and the extensive data collection's over, then their schedule liberalizes a little bit. It changes somewhat, allows them, like you say, to go to the office and do some work, catch up on email, those sorts of things. And the debriefs will continue during that time, and they need to, because we want them to pass on this information while it's still fresh in their heads. But their rehab program continues, and at least 2 to 2.5 hours will be dedicated to rehab each day for that 45-day window. And in fact, with Dr. Whitson, we plan to break it into 2 sessions and have 2 rehab sessions each day for her, as she is real anxious to get back to her 1G form as quickly as possible. And so we'll keep her on range. We won't let her go too fast, but at the same time, we want to allow her to get back into shape. And I don't think she's going to have that far to go personally. I think she's going to be coming back in very good shape. At least all the tests we've done on orbit, and we do those regularly. Every month we do a physical fitness test, and her tests have shown outstanding results. She's maintained her cardiovascular system as well as it was when she launched. And so I don't think she's going to have a big delta. The main thing will be in the strength and endurance of her muscles, and we'll have to get that back. And it'll be very interesting to see how much bone she's lost, considering how well and how much of the resistive exercise she's accomplished during her stay on orbit.
Thanks. I do have one more question. What's the difference in the way your astronauts approach this? I know, you know, on Earth, exercise, some people love it, some people don't. Is that true in space? To the people who really push themselves to follow the protocol, are they the ones that come out with the best results when they get back to Earth, or do you think there are other factors that may have to do with genetics or psychological factors? Do you really kind of know what works best, the formula?
Well, I think you've hit upon a very important point, and part of the reason we have this space station is to do this type of science, to understand what are the best countermeasures for long-duration flight. If we ever want to go back to the moon and on to Mars and places like that, we need to know how to protect crew members, and so this is part of the science we are doing. And some of the science on this particular expedition, we're looking at those types of things, looking at how well the bone is preserved, looking at the preservation of the pulmonary function, the lung function during their stay on orbit, looking at their ability to maintain their neuroproprioceptive system, their sensing in one gravity when they come back. So all of those are under investigation. Our current mode of thinking, however, is that the countermeasures program is the best way to preserve function while they're on orbit. And the countermeasures program we're talking about is the exercises, the pharmacologic regimens that they get recommended, et cetera. So yes, we think that the compliance with the regimen is associated positively with the outcome at the end, how well the crew members return, but there clearly are some genetic influences, and it's hard to predict because we don't understand all the genetics of spaceflight and adapting from 0 gravity to 1 gravity. And so that's part of the science we need to do to understand those so we can better target future therapies.
Endeavour Houston, good morning and happy Thanksgiving. LA, we were told that you traditionally watch the movie Trading Places on Thanksgiving Day, wherever you are and with whomever you're with. Since that might not be the case today, Dario and Nico thought that we should play Figaro's Wedding, which, as I'm sure you know, is the music played in the opening scenes in the movie. They also wanted me to wish you a Merry Thanksgiving.
Sounding good, Joni.
You're looking good, L.A.
Yeah, thanks. That's great. Very inspirational. We're pumped up, ready to go. I could just see my suits being arranged and you guys making fresh squeezed orange juice for us down there. And we're looking forward to a great day. And we all miss our families, and we're sorry that you are all having to work on Thanksgiving, but it's all for a good cause. Thanks very much.
You're quite welcome, and we're happy to be here to support you. And we also look forward to an awesome EVA today.
The first task is installing a couple of fluid jumpers between S0 and P1. They were launched on the S0 truss during 8A. They were launched with nitrogen in them, and they will eventually carry ammonia when the trusses are filled on 12A.1. Both crew members worked together to retrieve these two jumpers, and then they pre-positioned them near the installation work site. John and Mike worked from foot restraints to install the jumpers. They're about 3 inches in diameter, and they're challenging to manipulate. After they get them installed, they'll open the valves one at a time so that MCC can do a leak check on the jumpers. Next is removal of the starboard kill pin. Again, the kill pin has to be removed in order for the CETA and the MT to translate down the truss. Each crew member removes one bolt, and then they use the CETA cart to take the kill pin to its stowage location. And here you can see Mike already in the foot restraint. After the kill pin's removed, John ingresses the CETA cart on the other side, and while Mike holds the kill pin, John manually translates the CETA cart to the stowage location. John gets out of the CETA cart to help Mike put the kill pin in its stowage fitting, which is down inside the truss, and then they latch it in place with a bracket and a pip pin. Now they head to do the P1 WETA installation. Mike will take the CETA cart, which has the wetter stored on it, down to the end of the truss. They'll install the WETA antenna onto the stanchion and then take the stanchion off of the kill pin. This WETA is installed at the portmost end of P1. Again, Mike will engage one bolt and then mate the 3 connectors that provide the power and video. While he's doing that, John will be releasing line clamps that are on electrical harnesses that need to be mated on 12A. He'll also test the P1 to P3 ready to latch indicators to make sure they're working right before we need to add the next truss. Now this is removal of the last kill pin. This is the CETA cart translation part, and again, Mike is holding the kill pin while John translates the cart. The last task is the CETA cart relocate to the other side of the MT. As Mark told you in an earlier briefing, we have to do this in order to get the MT to translate to the end of P1 to support EVA 3. Mike will release 2 wheel bogies, and then John from the arm will carry the CETA cart, which weighs about 600 pounds. This is the end of the arm maneuver for the CETA relocate. Both crew members will work together to reposition it on the rails, and then Mike will engage wheel bogies to lock it down. Now we'll couple the 2 CETA carts together. After this point, when the MT translates, it will pull both CETA carts along with it.
This is Mission Control Houston. We're receiving live video from the International Space Station. You're looking at the Quest airlock. It'll be out of this airlock that the 2 spacewalkers, Michael Lopez Alegria and John Harrington, will emerge around 1:20 p.m. Central Time.
And behind Don Pettit, you can see the 2 spacewalkers in their suits as they are continuing their pre-breathe of pure oxygen to cleanse the nitrogen out of their bloodstreams prior to the start of today's spacewalk. A short time from now, Lopez Alegria and Harrington will make their way from the equipment lock, which is this innermost chamber in which they basically suit up and prepare for a spacewalk. They will move into the outer chamber directly behind them. That's the crew lock portion. Close the hatch behind them and wait for the green light to bring the crew lock down to vacuum prior to the opening of the hatch and the placement of their suits on internal battery power for the start of today's spacewalk. Be operating the station's Canadarm2 robotic arm later in today's spacewalk from a workstation in the Destiny laboratory to move John Harrington around about 200 degrees as he manually relocates the crew equipment translation aid, or CETA cart, as it is known, the handrail cart, from the P1 truss over to the starboard truss segment to move it out of the rail system on the trusses. That will permit the mobile transporter, the base for the station's robotic arm during most instances, to be able to move freely up and down the rail system from one work site to another, positioning that mobile transporter for future assembly work. John Harrington is currently being equipped with a so-called SAFER unit. That is an acronym for Simplified Aid for EVA Rescue. It's essentially a device that contains small propulsion gas jets that would be used in the very unlikely event that a spacewalker would become untethered during his or her spacewalk, to help propel that spacewalker back to the safe confines of the International Space Station or a shuttle payload bay. Again, you're watching in the foreground here Expedition 5 Commander Valery Korzun working with Don Pettit, who's in the lower right-hand portion of your screen, and pilot Paul Lockhart, the spacewalk choreographer for this mission, in preparing John Harrington. They're reorienting him and basically moving him into the crew lock, the outermost chamber, where he will join Mike Lopez Alegria, positioning themselves in the correct configuration before they close the hatches. Those 2 crew members are continuing to pre-breathe pure oxygen prior to the start of the depressurization of the crew lock, which is about 30 minutes away. Now back to downlink television through the International Space Station's KU-band communication system. Again, Paul Lockhart in the foreground, Don Pettit preparing now to close the hatch to the crew lock. The spacewalk officers in mission control and the environmental systems officer reports that the crew lock is now at 5 pounds per square inch and holding. This, again, the intermediate step to permit a checkout of suit systems prior to bringing the crew lock down to vacuum. Close-up look at the hatch and the outer thermal cover on the Quest airlock, from which Lopez Alegria and Harrington will emerge a short time from now to begin the second of 3 spacewalks on this mission, continuing the outfitting of the Port 1 truss segment. The sequential still video system on the Shuttle Endeavour through the S-band communications capability of the orbiter in the absence currently of a KU-band downlink TV capability, which is in blockage, showing the opening of the outer thermal cover on the Quest airlock in preparation for the actual opening of the hatch itself by Lopez Alegria and John Harrington.
Copy.
Mike Lopez Alegria emerging from the Quest over China as Endeavour and the International Space Station are orbiting at an altitude of 248 statute miles, about to begin a northwest to southeasterly swing across the Pacific Ocean. We're about 13 minutes away from an orbital sunrise, and the resumption of television from the shuttle is about 31 minutes away.
Hey, John, rather than put it on the handrail, do you mind if I just put it on this little D-ring that's on the hatch, the circular hatch? Be a little easier, shorter for you to have to translate. I'm good, as long as I can't catch it on the way out. Fine. I'm going to release it. When you're ready. I'm ready.
Mike Lopez Alegria on the left, John Harrington on the right, in the vicinity of the handrail cart on the lower segment of the Port 1 or P1 truss, having stowed the wireless television antenna for the time being, as they prepare to begin the step-by-step procedures involved in about an hour-and-a-half long task to install and connect fluid jumpers between the P1 and S0 trusses.
Watch your stress state is kind of hanging up on stuff. We don't want that thing to work its way loose. Okay? Okay, good job. I think that's exactly what we wanted. It looks lit. It looks lit now, Paco. Yeah, it's lit now. I'm getting video. Thanks.
From the external television camera on the Destiny Laboratory, an excellent view of Mike Lopez Alegria on the left and John Harrington on the right as they begin preparations for the fluid jumper installation task to connect these fluid lines between the S0 and P1 truss structures. A moment ago, Commander Jim Weatherby on board Endeavour delivered a Thanksgiving Day message from aboard the orbiter as the 2 spacecraft approached the west coast of South America. We'll take a listen now on a replay of Jim Weatherby's Thanksgiving Day message from 248 miles above the Earth.
Houston, Endeavour, air ground 2.
Endeavour, Houston, we're with you, air to ground 2.
From the crews of Endeavour and Alpha, we wish everyone below a happy Thanksgiving. From our vantage point high above the Earth, we can see we are very fortunate to be living in a time when society has advanced our technology farther in one generation than in all of human history. We developed powered flight 1 century ago. For me, it began when I participated merely by sitting alone and listening to the greatest flight of all, Apollo 8, where for the first time in human history, 3 men got up one morning and left. I was captivated listening to my little 9-volt transistor radio as they passed around the backside of the moon, totally cut off from the other 5 billion of us on the planet. Now as we float here looking at what is being built, we consider ourselves extremely fortunate to be part of this generation that is expanding technology.
And lastly, we are grateful for our families and friends, for without them, this technology would be meaningless. From the crews of Endeavour and Alpha, we wish all of you closer to the center of our home planet a happy Thanksgiving.
Endeavour Houston, Wex, we pass along our thanks to you and your crew.
From the crews of Endeavour and Alpha, we wish everyone below a happy Thanksgiving. From our vantage point high above the Earth, we can see we are very fortunate to be living in a time when society has advanced our technology farther in one generation than in all of human history. We developed powered flight 1 century ago. For me, it began when I participated merely by sitting alone and listening to the greatest flight of all, Apollo 8, where for the first time in human history, 3 men got up one morning and left. I was captivated listening to my little 9-volt transistor radio as they passed around the backside of the moon, totally cut off from the other 5 billion of us on the planet. Now as we float here looking at what is being built, we consider ourselves extremely fortunate to be part of this generation that is expanding technology. And lastly, we are grateful for our families and friends, for without them, this technology would be meaningless. From the crews of Endeavour and Alpha, we wish all of you closer to the center of our home planet a happy Thanksgiving.
Endeavour Houston, Wex, we pass along our thanks to you and your crew.
Lopez Alegría is in the process of opening up the shrouds, connecting certain jumper lines on the S0 and P1 truss areas. He's also pulling back quick disconnect covers in preparation for the demating and remating those jumper lines between the 2 trusses. So we are now well into the S0 P1 fluid jumper installation procedures as Lopez Alegría and John Harrington continue their tasks now 1 hour into today's spacewalk.
Veo muchos chilenos.
John Harrington at the bottom of your screen, Mike Lopez Alegría at the top of your screen as they work on the initial procedures to remove this large keel pin from the starboard side of the port 1 truss.
Or whatever it was, they got the guy's hands, gloves dirty on 9A, happening to me. And I have not touched the interior of the bolt, just the, well, it's not true. It's the cylindrical part, but it's the large diameter cylindrical part. Putting the tool on, and I'm going to start turning it. I'm stopping on what? I got 20 turns, but I might have put a turn or 2 on by hand. Green torque light. Yeah, it looks like 6.3 max torque. Hard for me to read. Sounds good.
You're looking over the shoulder of Mike Lopez Alegría as he uses a power tool, a wireless power tool, basically a cordless pistol grip tool that is battery powered, removing bolts that are holding the starboard keel pin of the port 1 truss in place. Again, that keel pin is a large V-shaped metal bracket that held the port 1 truss in Endeavour's cargo bay during launch.
We're clear. You're good to start moving the cart gently. Similar. Let's make a release.
And the handrail cart, the CETA cart, now in motion, the handbrake having been released. Mike Lopez Alegría at the top of your screen, John Harrington on the opposite side of the CETA cart. As they now move down the P1 truss to stow the keel pin, the starboard keel pin, that has been removed from the truss structure itself.
If possible, I have the bolt started. I'm going to go and put the tool on it now. How do you like this vehicle? Well, it's like ice on a hot stove. bag. Says width. Alpha 5, clockwise 2.
A good view through the shuttle's payload bay cameras, showing the two spacewalkers at the end of the 45-foot-long, 14-ton Port 1 truss segment of the International Space Station, continuing to work on all of the bolts required to install a television antenna assembly at the end of that truss for wireless TV capability for future spacewalkers.
I had my tether was wrapped around an ORU, and so it was kind of this four-man spare lead, so the tether shuttle was way over there. Yeah, I kind of pulled on it a couple times, freed it from that tether point, and all of a sudden there was a straight line between me and the tether, and it came tether shuttle. Came scorching at me. Sounds like my dog on a leash. Take a look over the edge of P1. Roger, hang right there and I'll record that. That's a view you don't see every day. Just a little bit. That's why LA moved out of position.
This shot of Mike Lopez Alegria and John Harrington moving down the length of the Port 1 truss structure on the handrail cart to stow this second and final launch restraint, the port keel pin, in the framework of the P1 truss. This handrail soon will be removed from the P1 truss and manually relocated over to the starboard truss by John Harrington, as he will be working at the end of the station's robotic arm, which is at the top of your screen.
Want some video of that? Or where the pistons are? Not necessary. Okay. I think we're complete. We are. Good job, guys.
Mike Lopez Alegria on your right, John Harrington on your left, as they crawl along the length of the P1 truss on the handrail cart, having now stowed the port keel pin launch restraint within the framework of the truss itself. That task having been completed, they're going to move on now to a get-ahead task to release radiator launch locks, and then we'll begin the work to relocate that handrail car that they're currently transporting themselves on from the Port 1 truss over to the starboard 1 truss, with Harrington affixed to the end of the station's robotic arm that you see prominently displayed here in the field of view.
Set the parking brake, building it. I'm going to start stowing the brake handles forward. Michael, whereas we do those good motion, keep it coming zenith. Continuing zenith. And let's go station starboard another foot. Station starboard 1 more foot.
And now we have downlink television pictures from the International Space Station, as we can see the two crew and equipment translation aid carts side by side on the railway system of the station's truss structure. John Harrington getting off of his foot restraint on the space station's robotic arm.
Node forward starboard. Node forward starboard. About
This is Mission Control Houston with some downlink television pictures of the I'll take a look. The International Space Station truss structure. At the very top of your picture, you can see Mike Lopez Alegria with the red stripes around his legs, maneuvering back into position to help John Harrington, who is at the crew equipment translation aid cart on the starboard side of the truss structure, beginning the cleanup activities for this spacewalk.
Understand you just want it nadir now to get it out of your way?
Yeah, no, I want to look at the, there's a small...
So far today, spacewalk 5 hours and 32 minutes in length. All of the major objectives completed, along with a couple of get-ahead tasks.
We got to go to maneuver back up there and let John work.
Okay, maybe we should think about one last time to make sure we have everything. You already put one tether shuttle away. Both safety tethers are put away. I have the other tether shuttle. I have the ball stack, the scoop, and the crew lock bag, and the dummy box. Where is the ingress aid? Ingress aid is on the EPFR. Okay, I see it. Okay, we're good to go. Y'all watch the tether here. Harry burns himself. I was planning on it. We're about out. I'm not. I got a whole bunch.
Okay, guys, you got time to go over a couple more things?
Yeah, sure. How much daylight do we have left, Paco? Must be eating turkey.
A good look here at John Harrington as he is at the airlock hatchway. He and Mike Lopez Alegria finishing up their cleanup activities, taking tools and refuse from the spacewalk into the airlock.
Let's go ahead and go on in, and I'll get your stuff. Thanks, that'd be helpful. Yeah. Take it out? Did you take it out? Yeah. There you go. Okay, before we go again, thanks to the MCC team for what I think was a successful EVA, but we certainly couldn't have done it without you. We stand on the shoulders of giants. And I'm going to hardline now.
Thank you from Houston.
Guess what time it is now?
Sleep time?
Getting close. Time for you guys to have pumpkin pie and for me to wish you a happy Thanksgiving.
We have definitely enjoyed all of our wonderful dinners and desserts, and we hope you enjoyed your Thanksgiving up there too. Thanks a lot, Mike.
Good evening and welcome to today's STS-113 mission status briefing. With us this evening are, from my right, Bob Castle, STS-113 Mission Operations Director, Dana Weigel, STS-113 Lead EVA Officer, and on the far right is Eulalio Nandine, STS-113 Launch Package Manager Team. Bob, would you start, please?
Okay, thank you. Well, hope everyone had a happy Thanksgiving today. I've had a pretty happy Thanksgiving so far today. Things have gone very, very well again. We've completed EVA 2 today on today's flight day 6. The EVA went very, very well. I'll let Dana go into the details of what happened, but everything went very well. We picked up everything we planned to do, as well as a couple of get-aheads, and actually ended a little bit early. As far as other things going on, the transfers have continued. We think we're on track with all of that. Crew handover, of course, continuing to do handover briefings to get the new crew up to speed on things going on and how things really work once they get there. All that's gone very well. We are currently looking to another day tomorrow, which will be mainly a transfer day, as well as our second reboost opportunity. EVA 3 is still on schedule for Saturday, and then the plan would be to continue to undock on Monday, and then landing on Wednesday. So at this time, there's no move to extend the mission any. We're still looking at a nominal length mission with, I think, everything we're planning to do getting done so far. So I'm not much more to say, really. Go on to Dana.
Thanks, Bob. As Bob already mentioned, the EVA today was very successful. The duration was 6:10, and for folks that are counting the details, that's 6 hours, 10 minutes, and 33 seconds. And just to recap the nominal tasks that we completed today, we installed 2 fluid jumpers that currently carry nitrogen. They're mated between S0 and the P1 truss. They'll eventually carry ammonia on 12A.1. We also installed 4 spool positioning devices on those jumpers. We removed both of the keel pins that were on the truss. We installed another wireless video system antenna. This one was at the end of P1. And at the end of the day, we relocated the CETA cart to the other side of the MT. We also picked up a couple additional tasks, a couple get-ahead tasks. We released 7 of the 18 radiator beam launch locks. That's a task scheduled for the stage EVA, so we were doing that early. We mated a wireless video system connector that we would have done on EVA 3. We got that done today. And we also sewed a couple of tip pins that came loose from the hatch. With the completion of the EVA, the truss is configured so that the MT can run down to the end of P1 to support EVA 3. We also have both wireless video system antennas up and running. So the stage EVA, the increment 6 stage EVA will have wireless video or EVA helmet video capability. And that's all I have for my update. Eulalia.
Well, I'll take a moment to thank the crew, MOD Flight Control Team, and MER, and all the support personnel who had to leave their families during Thanksgiving to make all this happen. Today, we literally cleared the path for 12A. And we're thankful for that. I'll pass it on to Bob.
Great, thanks very much. We'll take questions now, starting here at Johnson Space Center. Please remember to state your name and affiliation and wait for the microphone. Mark?
Mark Carruth from the Houston Chronicle. When does the mobile transporter move, and what are the main tasks of the third spacewalk?
The MT will move the morning of EVA 3, and it aligns basically with when the crew is starting to get in their suits. So the sequence for that day is crew starts getting the suits, the MT moves out to the end of the P1 truss, and then the SSRMS will do a walk-off onto the MT. And by the time we get out the door, it's in position for our first task. Our first task that John does uses the arm. He'll install spool positioning devices on the radiator beam valve modules. He'll be doing 18 of them. And just really the summary of EVA 3 is that we're spending the whole time installing these spool positioning devices, and I could go through all of the different tasks, but let me just say that we're doing a collection of those, and then we're doing a systems checkout on the S1 and P1 DC to DC converter units and some electrical rewiring, and that's pretty much in a nutshell what EVA 3 is about.
Okay, and I'd like to ask a follow-up question on the so-called get-ahead task that you did today regarding the launch locks on the radiator. Was there any particular reason you moved that up? And I guess what I'm really sort of wondering is, do you have other tasks for the spacewalk planned by the 2 expedition crew members in December?
We do have other tasks planned for them, and their EVA right now is plenty full. So us doing a couple launch locks actually helps them out. That's actually a benefit for them. Anytime, I think you asked kind of generically why we considered maybe doing these get-aheads. Anytime you have additional EVA time, you're already out the door, you might as well use the time as long as it doesn't risk going too long. And in this case, the radiator beam launch locks are very simple. They take about 5 minutes apiece. They're low risk and they're easy to break out of them or leave them if we started going long. So it was a very clean task for us to put in there, and it does help the stage EVA.
Yeah, I had just one more spacewalk question. Is there anything about the configuration changes that you made today that helps you with the change out of the control moment gyro, or was that already taken care of with the positioning of everything prior to the spacewalk? I'm just wondering if it helped that task in any way, or that's completely a separate.
That's separate. None of our tasks today were dedicated or involved in the effort of recovering that CMG.
And I believe that was our last question from Johnson Space Center. We'll move now to Kennedy Space Center.
Yeah, hi, it's Bill Harwood with CBS again. I think I'm the only guy here. I know I'm the only guy here. For Dana, I was just curious, I meant to ask you this earlier, and I can't find this in my notes anywhere, and I know you said this at the pre-flight briefing, but how long did it take the mobile transporter to go from 4 to 7?
The entire procedure is book kept for an hour and a half. Part of that is the unlatching of the mobile transporter, unplugging it from its electrical source and the drive time, and it moves at about 1.2 inches per second. And I think we figured, I can't remember the number that I had there, but I think that was somewhere in the order of 55 feet or so. But anyway, the whole procedure we bookkeep is an hour and a half, and a portion of that is the actual motion.
And this is probably a dumb question, but I mean, if the thing got hung up somewhere between 4 and 7 for whatever reason, I assume then you would send the guys out the hatch and start doing some kind of contingency right off the bat. Is that right?
Right, that is true. We actually have a couple of procedures in place. We have a couple different contingencies we could do to recover power and make sure that it was stable.
Like cut the cable, I guess, or something like that?
Well, if the EVA crew was out there, we wouldn't actually have to cut the cable. We can just manually disconnect the connectors. And if the problem is a mechanical jam in the cable that feeds out as it's moving, then disconnecting the connectors would allow you to continue driving the MT down to the next work site. If that's not the problem, then we can run a contingency harness to it, basically plug into like an auxiliary port and leave it powered out there.
Forgot about that extension cord. And could you, and following Mark Carreau's question, looking at 12A and the flights coming up, I realize that's probably not your flight, but can you give us a sense of what the arm has to do? I mean, the movements that are required. I know you're going from 4 to 7 tomorrow, then you go back to 4, and then I guess for 12A you move back out to 7, or what's the scenario?
That is accurate. We do go from 4 to 7, and then we go back to 4. The general goal is always to bring the MT back to work site 4. The cable that we were talking about earlier, the trailing umbilical system cable, the TUS cable, we don't want to leave it out there exposed. So we always go back to work site 4. And on 12A, I don't know the specifics of their arm trajectory, but they do go back out to work site 7, and they use the arm from that work site.
Okay, but you're saying after any generic station assembly EVA, the goal is to bring it back to 4, I guess.
That's the current goal.
Thanks. And one for Bob Castle. Bob, I've been watching you up there for more years than probably either one of us want to think about. You know, I was talking to somebody about this EVA today, and how if you look at the last several space station assembly missions, they all have really gone remarkably well. And just, 5 or 6 years ago, people were talking about the wall of EVA, and geez, this is really going to be tough. And it really has been made to look simple. I know it's not, but it's gone very smoothly. I was just wondering what your thoughts are when you look at all of this in context, from where you were when you started to where you are today, when this is just kind of bang, bang, bang.
Well, you're right. It has been more years than I want to remember. I think the main thing is people got really serious. When we saw the wall of EVA, people ramped up to it as a challenge. And I've been very impressed with how well this team and the various teams have overcome that challenge and as you say, made it look easy. Launching the shuttle is made to look easy. It's not. All these EVAs are made to look easy. They're not. But I think it's really the fact that we recognized the challenge and went after it and worked so hard to overcome it and saw it was coming. That is really the difference that I'm seeing, and why I'm very happy to see them go, as you say, just boom, boom, boom. They're going very, very much by the clock. But I would attribute just the fact of preparation that we knew they were coming and got prepared for them.
Thanks. That's all from here. Happy Thanksgiving, you guys.
Do we have follow-ups here at JSC? Mark?
Yeah, Mark Carreau from Houston Chronicle. I just had one more question. I know you're not looking at extending the mission at this point, but I just wonder if you have reserve for power and electricity, if that was necessary, what you have, if you could go an extra day if you had to.
The answer to that is yes. We do have the reserve. The limiting consumable right now is going to be power or cryogenic oxygen, hydrogen, but we do have enough for a total of 4 extension days, of which we need 2, desire 3 for the shuttle to make sure we can land at Kennedy. So we could go an extra day here with no particular big deal. It's just simply a matter of will the mission fit. You always like to go get your mission done, and then when you're done, you go land. If you need it to get the mission done, well, we'll extend. Right now, it doesn't look like we're going to need it, but we do have cryo for a total of 4 extension days.